Hello and welcome. Sorry. Hello and good evening everyone guys. I welcome you all to this wonderful channel of Unacademy NEET English. I believe you all are doing great and having a good time. Well, my name is Kar Khurshid Alam. You can also call me KK sir. But before we move ahead, I want quick confirmation that if you can see me clearly and hear me clearly, let me know in the chats. Let me know in the chats, my dear students. Let me know in the chats. Okay, I believe that we are live now and super excited for today's session. We are going to deal with some top-notch, top 100 amazing questions. For sure, it will be a never-before session. So, you have to be with me till end of this session, as I believe many questions from this session will show in your finals. So, mark the attendance by smashing the like button and do share the stream with everyone around. So, let me know in the chats how is the Josh. Let me know in the chats how is the Josh for today's session. Come on quickly. Let me know in the chats that how is the Josh for today's session. As today's session is very important session. I believe many of the questions from this session will show in your finals. So how is the Josh, my dear lovely doctors? Good evening, good evening. That's great, that's great. Josh is high. I think Josh is high. Come on, come on, come on. You can put some fire emojis. Okay. Yeah, I'm always there. I'm always there to help. I'm always there to help. MS Angel Harshini. Don't worry, I'm always there. Don't worry. So Josh is very high. Josh is very high. Okay, that's great. That is great. Do share the stream with everyone around, as this session is gonna be very important for you. For every NEET aspirants, this session will be very important session. My organic is weak, sir. Please help. I'm always there. Don't worry. Don't worry about your organic chemistry. I'm there. I'm trusting only you for organics, sir. Thank you. Thank you. God bless you. God bless you. God bless you. So, without wasting time, let's get going. Now, first question of today's session is that you are having some compound is given over here, and that compound is, let me write down over here. Compound is CH3, CH, then it is CH2, then it is CH2, then it is OH, and after that, here it is the CH3. Now, first of all, we know we have to, find out the parent chain, and our parent chain is this. This is the parent chain. Now, finally, we will number the parent chain in such a way so that the functional group OH attached to the carbon gets the lowest number. So it is like this. So this is outside the parent chain. So this is the substituent or the side chain. So can we say it is 3-methyl? It is 3-methyl. After that, word root is but. All these carbons are having single bonds, so N, but final E will be lost or omitted as OH starts with, all vowel. Whenever functional group, whenever secondary suffix starts with a vowel, you have to omit, you have to elide, you have to drop final E. So the name of this compound is 3-methyl butan 1-ol. So 3-methyl butan 1-ol or 1-butanol is the right option. I hope this is very easy, but believe me, these types of questions will be asked in your NEET examination. So be ready for that. Now, let me know in the chats. Yes, 4 is the right answer. You have to be with me. You have to answer each and every question so that I can understand that you have already, studied each and everything. You are ready for your NEET examinations. So, next question will be, once again from organic, this nomenclature, organic nomenclature. So, the question is like this. It is like this. It is like this. Now, as we know, this is the functional group. This is the functional group of ester. This is the functional group of what we call ester. So, when main functional group is ester, we have to write down that alkyl which is attached to oxygen of ester first. So, I will write down ethyl, as C2H5 means ethyl. After that, I will number from this one. So this is 1, this is 2, this is 3, this is 4. This becomes what we call the substituent. So substituent is CH3O, that means methoxy. So it is 4-methoxy. Ethyl first, after that substituent, after that word root. Word root is number of carbon atoms present in a chain, that is, 4. After that single bond, and then it is 1-OH, because we have to write down the name of ester in such a way that alkyl first, then name, and OH at the last. That means its name is ethyl 4-methoxy butane 1-OH. That means what we call ethyl 4-methoxy butanoate or butane 1-OH. Why 1 is not necessary? Why 1 is not necessary? Because this is the chain terminating functional group. It will be always at position number 1 when it acts as a functional group. I hope this is clear to you all. I hope this is clear to you all. Great. You have to write down the answer. You have to write down the answer as well. So that this session will be, sorry, my basically throat is a little bit, I'm having sore throat exactly, but we will not stop. We will not stop, because if my throat is aching, if my throat is, if I am having a sore throat, but we will not stop, as this time is very, very, very important for my doctors. So this whole time, my whole time is for you, my dear lovely students. So let me know the answer of this question before I answer the question. Let me know in the chats what will be the answer of this question. Let me write down what is, the compound over here. Compound is like this. It is like this, my dear doctors. It is like this. It is like this. Let me know quickly. Let me know quickly what will be the answer. What will be the answer? 4, 4, 4, 4. Now, 4. Now, have a look. Have a look. Have a look. Have a look. Whenever you are having a compound like this, you know, if this, this benzene acts as a parent chain, at that time this chlorine and this methyl will act as substituents. Then this starts with chloro, starts with C, methyl starts with M. So we have to number the parent chain in such a way that what we call substituent, which comes first in alphabetical order, will get lowest number. So its name at that time will become like this. This is 1, 2, 3, 4, 5 and 6. So its name will become 1-chloro. 1-chloro, and then it will be 4-methyl, and after that it will be benzene. So this is one of the name of this compound. But if we treat this as toluene, special name of this methyl benzene, if we treat this as toluene, then this chlorine is present in toluene at 4th position, because then we have to number from this position to which methyl group is attached. So this is 4-chlorotoluene, or we can simply say its name is 1-chloro-4-methyl-benzene. That means 1-chloro-4-methyl-benzene is exactly correct. 4-chlorotoluene is exactly correct. That clearly indicates our option number 4 is the right answer. That's great. That is great. That is great. Come on. Come on. Let's have another example. Next question is like this. Next question is like this. 3 structures are given. First structure is like this. First structure is like this. Let me know quickly. Let me know quickly what will be the answer. First structure is like this. Second structure is like this. Second structure is like this. And third structure is like this. Third structure is like this. Third structure is like this. Now, what we have to tell? We have to tell which among the these compounds can exhibit tautomerism. Which among these can show tautomerism? Come on, let me know quickly. Let me know quickly. Which can show tautomerism? Which can show tautomerism? Is this one only? Is this only? Or is this two only? Or both 1 and 2? Or both 2 and 3? Let me know quickly. Let me know quickly. As this question is basically of ketoenol tautomerism, and we know for ketoenol tautomerism there must be enolizable hydrogen if ketoforms are given. Here no hydrogen is enolizable. That means no hydrogen is present at sp3 hybridized carbon, because there is no sp3 hybridized carbon, so it cannot show tautomerism. But this is sp3 hybridized carbon, and hydrogen attached to this can migrate and it will show tautomerism. Similarly, this hydrogen can also migrate and will show tautomerism. That means this can show tautomerism. What about this? This is not having any sp3 hybridized carbon to which hydrogen is attached. Hence, this will also not show tautomerism. So, tautomerism is shown only by this 2. Tautomerism is shown only by 2. Is this clear to each and every one? Because there are conditions for tautomerism, and compound second is fulfilling the condition. Okay, after that. Next question will be once again from isomerism. CH3CONH2 and HCONHCH3. What is meant by that? That means one compound is like this, CH3CONH2. Another compound is like this, HCO double bond, then NH, then CH3. What is the molecular formula of this compound? This is carbon having C2, hydrogens, say 5, then nitrogen is 1, oxygen is 1. What about this? Carbons 2, that means C2, hydrogen is also 5, then nitrogen is 1, oxygen is 1. That means they are having same molecular formula, but compounds are different. When compounds are different, having same molecular formula, they are known as isomers. Now the question is, which type of isomers are these? Are they position isomer, chain isomer, tautomer, or functional isomer? Have a look. This type of compound in which CONH2 is the functional group, this is known as primary amide, and in which CONH is the functional group, this is known as secondary amide. And you know that primary amides and secondary amides having same molecular formula are known as functional isomers, because they are having different functional groups. So functional isomer is the right option. Now let me know quickly. Is this clear? Let me know quickly. Is this clear? Is this clear? My dear lovely students, let me know. Is this clear? Is this clear? Okay, that's great. That is great. Now after this, the number of structural isomers possible for the molecular formula C3H9N. Have a look. Molecular formula given is C3H9N. First of all, you must calculate degree of unsaturation. But how to calculate degree of unsaturation? No need to memorize formula. You can calculate its degree of unsaturation like this. You know, this nitrogen is a trivalent species. Whenever you are having a trivalent species, just remove that and remove equal number of hydrogens as well. That means its formula becomes C3H8. Now, compare this formula with alkane. Alkane is having general formula CnH2n plus 2. Now, here N value, that means carbon, N value is 3. So if N is 3, now tell me what should be the molecular formula of alkane. At that time it should be C3H8. That means this alkane and this formula, they are same. That means there is no difference in hydrogen at all. When there is no difference in hydrogen, we can simply say degree of unsaturation for such species is 0. What is meant by that? Degree of unsaturation or double bond equivalent or index of hydrogen deficiency is 0. That means there are no double bonds, no triple bonds, or no what we call cyclic structure present in C3H9N. Now I will erase this one and will show further. Now have a look. Now it's clear now that C3H9N is an aliphatic species, and that too having single bonds only. Now have a look. So we can simply say C3H9N is having the general formula CnH2n plus 2 H2n plus 2. Have a look. It is C3. That means C3. Then it is C6, not 3. This is H2n plus 3. So C3 H9. So this formula is of actually amines. So we know amines are of three types. Amines are of three types. One is 1 degree amine, another is 2 degree amine, another is 3 degree amine. Have a look. 1 degree amine means your functional group should be NH2. Then carbon should be attached on one side. Then we have secondary amine, that means NH. Then carbon should be on two sides. Then we have tertiary amine, carbon should be on three sides. Have a look. When we write, I mean to say this formula, so carbons are 3, so I will write down 3 carbons either in this way, or we can simply say carbons can be like in N-propyl form or isopropyl form. That means formula of this compound, first compound, is like this, or we can say formula can be like this. It can be like this. It can be like this. This nitrogen can be attached to this. That means once again it is NH2, but either it is attached to this carbon or to this carbon. If nitrogen is attached to this carbon, this and that should be the same. That means primary amines are 2. Here, secondary amine. One will be CH3 over here, and then CH2, CH3 over here. Similarly, if I put CH2, CH3 here, that is one and the same. So 1, 2, 3, and then tertiary amine will be CH3, CH3, CH3. So here will be 2 primary amines, 1 secondary amine, and 1 tertiary amine. That means there are 4 structural isomers possible. So option number 3 is the right answer. Let me know quickly, am I clear till now? Let me know quickly. Let me know quickly, am I clear till now? Am I clear till now? Am I clear till now? Let me know quickly. Let me know quickly. Rufizan is exactly correct. This third option is the right answer. Shafkat is saying clear, sir. Thank you. Vishwa is saying clear. That's great. Dr. Gulati, clear. At the rate of Akina, clear. Nice. Clear, 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 clear. God bless you all. God bless you all. Now, come on. Let's do another say question. Possible number of di-substituted benzene isomers. Now have a look. This is benzene. What is meant by di-substituted? That means if I write, say what we call resonating structure of benzene. So I will simply write down like this. I will simply write down like this. I will write down benzene in this fashion. Now, I have to put two substituents. Let us suppose G. G is the group, any substituent. So we cannot put two substituents at same carbon, because carbon forms otherwise 5 bonds, which is not possible. So this is not possible. This is not possible. After that, what is the possibility? What is the possibility? That one carbon, one substituent at one carbon, another at another position. That means ortho. That means 1, 2 di-substituted benzene or ortho di-substituted benzene. After that, we can put this over this and then another at meta. Another similarly at para. Another at para. That means 1, 2, 1, 3, 1, 4. 1, 1 is not possible. 1, 2 is possible. 1, 3 is possible. 1, 4 is possible. Someone says that 1, 5, sir. But 1, 5. How 1, 5? 1, 2, 3, 4, 5. But let me tell you, this is not 1, 5. This is once again 1, 3. That means it is this structure. So no need to draw this. Someone says 1, 6, sir. 1, 6. How 1, 6? 1, 2, 3, 4, 5, 6. But this is not 1, 6. This is 1, 2. That means it is this. That means this is one and the same. So only 3 isomers are possible. So this is the right answer. This is the right answer. I hope this is clear. I hope this is clear. Let me know quickly. Let me know quickly. Vishwa is saying third option, sir. Exactly third option. That is great. That is great. Come on, come on. Let me know quickly. Let me know quickly. Is everything clear? Everything is clear, sir. That is great. That is great. Now, next question. Next question is, which is incorrect? Which is incorrect statement? I am waiting for the answer of this question. I am waiting for the answer of this question from your side. Let me check how many among you can tell me the right answer. This is one, this is second. Second is like this. Second is like this. Second is like this. A very easy question. Let me know in the chats. Let me know in the chats which option is correct. One is Z. this is having Z configuration. Second is having E configuration. Third, 1 and 2 are geometrical isomers of each other. 4, none of these. Let me know quickly. Let me know quickly. Let me know quickly. Let me know quickly. I am waiting for your response. Before I show you the right answer, I want answer from you. Come on. Please do tough questions, sir. These are tough questions, Santosh. Let me know from you. What is the answer, Santosh? Come on. Let me know the answer. If this is an easy question, let me know the answer quickly in the chat. Santosh, come on. Come on, Santosh. Come on, Santosh. Let me tell you, and I assure you once again, Santosh, that your chemistry paper, organic chemistry paper from these sessions only. Come on. Let me know. Let me know, Santosh. I'm waiting for your answer. Tell me the answer, Santosh, if this is an easy question to you. Come on. Come on. Come on, lovely student. Come on, Santosh. Santosh is not replying. Santosh is not replying. Come on. Now, 3. Most of the students are saying 3. Now, have a look. Have a look. Have a look. At this carbon, can I say this I and Br are attached? I is having highest atomic number. That is why it got priority number 1. This got priority number 2. Similarly, at this carbon, this chlorine and fluorine are attached. So this got 1, this got 2. Now have a look. Across carbon-carbon double bond, 1 and 1, identical priority. 2 and 2, identical priority. They are on same side. Hence, we call this as Z isomer. Zusammen comes from the Greek word, German word, zusammen, which means identical priority groups are on the same side across carbon-carbon double bond. Now, have a look. What about this? This iodine is having priority number 1. Then, this chlorine is having priority number 2. At this carbon, 2 groups are attached. Now, at this carbon, 2 groups are attached. One is bromine, another is fluorine. So, 1 and 1. 2 and 2 identical priorities are on opposite side across carbon-carbon double bond. So across means Engagement. That means E, because it's a German word. Engagement means across. That means opposite. So this is Z, this is E. Both are correct. Z, E, both are correct. But you have to find out incorrect one. You have to find out incorrect one. You have to find out incorrect one. Now have a look. Have a look. Are these two geometrical isomers? Answer is no. Why? Because geometrical isomer means they are stereoisomers. And what are stereoisomers? Which are having same molecular formula and same structural formula. But let me tell you, these two are having same molecular formula, but they do not have same structural formula because they do not have same connectivity. Have a look. Carbon to which iodine is attached. Similar carbon is attached to bromine. That means iodine and bromine are attached to same carbon. But here, iodine and bromine are not attached to same carbon. That means connectivity is different. So they are having different structure. Hence, they are structural isomers. They are structural isomers. If they are structural isomers, they can never be geometrical isomer, because geometrical isomer means they are having same what we call structural formula. But they are structural isomer means they are having different structural formula. But geometrical isomer means they are having same structural formula. So this is the wrong option. Hence, we will write down option number 3. Great. Most of the students gave the right answer. That is option number 3. That's great. Santosh, your answer is wrong. You have given 4th option and you say that these are easy questions. Now, my dear lovely student, just wait and watch how these questions are basically. Now, Santosh is giving wrong answer. I was very much happy that Santosh was saying that these questions are very easy, but unfortunately, Santosh gave the wrong answer. After this, we will be having the geometrical isomerism is shown by. Geometrical isomerism is shown by, among these, I will write down option one by one. First option is this. First option is this. First option is this. This is the first option. After that, we will be having a second option. Second option is like this. Second option is like this. Second option is like this. After that, we will be having third option. Third option is like this. Third option is like this. Third option is like this. After that, we will be having fourth option, and fourth option is like this. Now you have to tell me that which among these show geometrical isomerism. You know, for geometrical isomerism there must be two atoms attached together in by means of such bonds which show what we call hindrance, or what we call there should not be free rotation, there should be restricted rotation. So we know between carbon-carbon double bond there is hindered rotation, but at the very same time this atom must have two different groups, but this is having same group, so it will not show. This is having same group, it will not show. Similarly, this is having difference H and Cl, but this carbon is having CH2 and then this group, CH2 and then this group, because you have to think like this side and this side they are same, that means this is not having different groups, hence this will not show the geometrical isomerism. What about this? This is having two different groups, hindrance is there. After that this group is different, have a look. This side is different as compared to this side. Similarly, H and Cl are different. So this will show geometrical isomerism. So write the option number 4 is the right answer. Exactly, most of the students are given option number 4. Exactly, my dear lovely students, exactly. And let me assure you once again that your NEET paper will be directly or indirectly from these sessions. So be with me till end of this session. Now, after this, we will be having another question. The number of geometrical isomers of CH3, CH double bond CH, CH double bond CH, single bond CH double bond CH, Cl are. As you know, this compound is unsymmetrical, and for unsymmetrical number of geometrical isomers is 2 raised to the power n. But what is this n? N means number of GI areas. Number of GI areas. Now we know GI areas here is this. This is first GI area, this is second GI area, this is third GI area. I mean, say these are the geometrical isomer areas. So we know geometrical isomer areas are 3. So hence 2 raised to the power 3 means answer should be 8. Answer should be 8. I hope this is clear to each and everyone. I hope this is clear to each and everyone, because this is the question which can be solved directly by using the formula. Now, after this, we will be having another question. Two compounds are given. Now, after this, 2 compounds are given, and you have to tell me that what is the relation between these two, whether they are enantiomers, identical compounds, optically inactive, or they are diastereomers. Now, compounds are like this. This is deuterium. After that, this is bromine. This is what we call hydrogen. This is chlorine. This is hydrogen. This is iodine. After this, we will be having chlorine, then it's hydrogen, it's iodine, it's hydrogen, it's deuterium, and this is bromine. Have a look. If we talk about this carbon, this carbon is what we call sp3 hybridized and is having 4 different groups. So chiral center, similarly chiral center and chiral center. So how will we simply say what is the relation between these two? We will simply assign configuration to this. We know this is priority number 1 to this, and with respect to this carbon, this whole group gets priority number 2. This deuterium is 3, this is 4, that means 1 to 2 to 3, that means clockwise. But as least priority is on horizontal line, use golden rule, so its configuration is S. What about this? This is first priority group. After that, this is second priority group, and with respect to this above group becomes third group, and this becomes 4 group. So 1, 2, 3, it is S, but S changes to R because of golden rule, because hydrogen or least priority group is present on horizontal line. Similarly, what is the relation? What is the configuration of this? This is 1, this is 2, then this group with respect to chiral center becomes 3, and this becomes 4. So 1 to 2, 1 to 2, 1 to 2, and 2 to 3. That means clockwise, but clockwise means R, but it is having S because of golden rule. Now what about this? This is 1, BR is 1. Then this group with respect to this chiral center will be 2. This will be 3. So 1, 2, 3. This is S. S changes to R due to golden rule. Now this is 4. Now have a look. We have to consider this carbon with this carbon. We have to combine these two. Why these two? Because this is the chiral center where BRD, H and other group, BRD and H and other group is attached. That means these are the similar positions. This position is having S, this is having R configuration. Configuration has been changed at this chiral center. What about this? This is R, here it is S. That means same chiral center in both compounds have different configuration. When similar chiral centers in different compounds have different configuration at all chiral centers, then we simply call such compounds as enantiomers. You know that. Then we simply call such compounds as enantiomers. You know that. Let me know in the chats, is this clear to you? Is this clear to you why they are enantiomers? Because their configuration at every chiral center is different. But you have to check this with this, not this and this, because these two are different chiral centers, similar chiral center. This chiral center is having S in one compound, similar chiral center in another is R, so configuration has been changed. Similarly, this chiral center is configuration having R, and similar chiral center in another is having configuration S, so configuration has been changed. When configuration at every chiral center, when configuration at chiral center in different compounds changes, that means is different, is opposite, we simply call that as what we call enantiomer. Okay, what is golden rule? Golden rule says, listen carefully. Golden rule says, whatever is the configuration in Fischer structure, you have to change that. If configuration seems to be R, you have to consider it as S. Similarly, if it seems to be S, you have to consider it as R. But when your least priority group is present on horizontal line, when your least priority group is present on horizontal line, have a look, I will help you. Have a look. If this is I, this is Br. This is having priority 1 because this is having higher atomic number as compared to Br. So this is 2. Then after that, this is Cl. Cl is having 3. Then this is H. H is having 4. Now, what should be the, say configuration according to 1, 2, 3? This is clockwise direction. So it should be R. It should be R. It seems to be R. But we will say it is not R. Why it is not R? Because least priority, that means fourth priority is present on horizontal line. Hence, it has to change from R to S. This is what we call golden rule. I hope this is clear to you now. I hope this is clear to you now. I hope this is clear to you now. So use golden rule only in Fischer structure. That means vertical and horizontal structure. And that too, if least priority group is present on horizontal line. If it is present on vertical line, you have not to use golden rule. Now, it's clear now. Okay, Ashwani. Okay. That's great. It's clear to you now. After this, A, B, C, D are resonating structures. A, B, C, D are resonating structures. You have to tell what is this B. You have to tell what is this B. What is this B? You have to tell what is this B. You have to tell me that what is this B? This B among these is, which of the following is B? First one is, let me write down once again. It is like this, HCOOH. That means this is the formic acid. One resonating structure of that formic acid. This is another resonating structure of formic acid. This is like this. Let me draw the structures once again. And its resonating structure is like this. This is the resonating structure of third, and this is the resonating structure of fourth. Now you have to tell me. By the way, before doing this, can you say what will be the order of decreasing order of stability? Which among these four will be the most stable resonating structure? You know, neutral resonating structures are more stable resonating structures. So first of all, I will write down stability order like this. 1. After that, use rule number 2. And what was rule number 2? Rule number 2 says that resonating structure having more number of pi bonds, basically more number of chemical bonds. But for trig, you can use pi bond. More number of pi bond, more will be the stability. This is not having any pi bond, this is not having any pi bond, this is having one pi bond. But after neutral, then I will write down 3. After this rule number 3. Rule number 3 says that structure whose octet of resonating structure in which all the atoms have complete octet is more stable. But this carbon is not having complete octet, this oxygen is not having complete octet. That means rule 3 cannot differentiate these two. After that, use rule number 4. What was rule number 4? That is, if you are having, say structures whose answer is not given by rule number 1, rule number 2, rule number 3, then you can simply say, if negative charge is present on more electronegative element, that is more stable, and if positive charge is present on less electronegative element, that is more stable. That means here, negative charge is present on oxygen and carbon. So we know oxygen is more electronegative. So On oxygen, negative charge is more stable. We know carbon is less electronegative as compared to oxygen. So positive charge on carbon is more stable. Hence, we can simply say 1, 3, then after that it is 2, then it is 4. So this is stability order. This will be the stability order of these resonating structures. Now have a look. If this is the stability order of these resonating structures, then what we have to do is, we will simply say that this is more stable. That means it's having least energy. So according to this, one according to this graph should be A. So 1 should be A. Why? Because this is most stable, means least energetic, because energy is increasing in this direction. After that, 3. That means it is less stable than 1, but it's more energetic than A. That means it is more energetic than 1. What is 1? 1 is A. More energetic than A is B. Similarly, can I say 2? 2 is C. Can I say this 4 will be D. But what our question says structure of B is B is 3. 3 means this one. So this is the right answer. So this will be our right answer. I hope this question is clear to each and everyone there. Let me know, is this clear? Let me know, is this clear? Is this clear? Is this clear? Okay. Screen is, this slide is not clear. I have shown 4 options. I will show this as well. Let me show this one. Let me show the graph as well. My dear lovely students, don't worry. I am here. Don't worry. I am here to help you. Don't worry at all. Unacademy is there to help you. So don't worry at all. So here energy is increased. Here energy is increasing in this fashion. So this is formic acid. Formic acid, I will draw structure like this. These structures are basically the resonating structures, 4 resonating structures of formic acid. One is A, another is B, another is C, another is D. Now tell me, if this is A, can I say A is less energetic? That means more stable, so it will be 1. Then after that, B is having more energy than A. If B is having more energy than A, can I say B is less stable than A? So this is B. After that, this is C, this is D. We have to tell what is B. What is B means? That means among 4 resonating structures, its stability should be at second place. Whose stability is at second place? It is 3. So that's why option number 3 is our, B. Is this clear now? Is this clear now? Is this clear now? My dear lovely students, is this clear now? Is this clear now? Is this clear? Is this clear? Okay, clear. So that's great. That is great. Now, after this, we will be having another slide. Let me write down these questions as well. First is this one. So don't worry, I will write down for you. Second is this one. And third is this one. What is the question? Question is rank the following in decreasing order of acidity. You have to rank these 3 in decreasing order of acidity. That means one which is more acidic, you have to write down that first, after that second, after that third. That means decreasing order of acidic strength, you have to tell me. Now for that, we will simply form conjugate base by removing H positive. Suppose H positive is removed, this is the conjugate base. Here H positive will be removed from this position so that this conjugate base will be stable because of resonance. Now this conjugate base is very stable because of aromatic character. So this is aromatic. Aromaticity increases resonance drastically. That means if it is aromatic, resonance will be very high. That means this is highly stable, and this is also stable due to resonance, but resonance in comparison to this is less, but there will be no resonance at all. So let me know in the chats, among these 3 conjugate bases, which one is the most stable conjugate base? This one. And we know acidic strength is directly proportional to stability of its conjugate acid. Now tell me 3, 2, 1. Which will be the acidic strength order? Can I say 3 will be most acidic, after that 2, after that 1? Now let me know quickly. Is this clear? Let me know quickly. Is this clear? Let me know quickly. Is this clear? Is this clear, my dear lovely students? Come on. Let me know quickly. Let me know quickly. Is this clear? Is this clear? Quick. After this, this is And another question for you. Let me know in the chats. The correct order of acid strength of the following compounds is. Now, A is phenol. You know phenol is this one. A is phenol. Phenol is this one. Then it's B. B is paracresol. Paracresol. You know, paracresol means phenol in which methyl group is present at, say para position. After that, third one is metanitrophenol. It is phenol at meta position, it is nitro group. After that, it is paranitrophenol. It is paranitrophenol. Come on, tell me the answer. Paranitrophenol. Then it's paranitrophenol. Now, you have to answer me the question. You have to answer this question. Now, what is this? This is phenol. Now, you know, acidic character. Acidic character can be find out like this. Acidic order. You can tell me acidic order like this. First of all, minus R, then minus H, that means reverse hyperconjugation, then inductive effect, then that which cannot show any effect. After that, plus I, after that, plus H, and after that, plus R. Remember, if you are having in these options, if you are having more than one minus R, then you have to write down first strong and then weak. Strong to weak. Similarly, if you are having these groups more than one, then you have to write first weak and then strong. So this is the order, and remember, you can write down acidic order of these. Have a look. This is phenol, phenol. But in addition to phenol, there is CH3 group at what we call para position. We know CH3 shows plus I as well as plus H. But as it is present at para position, distance is more, so we will not take, say inductive effect, we will take only hyperconjugation. What about this? This NO2 shows minus I as well as minus R. But as it is present at meta position, at present group present at meta position does not have any effect on acidic character or basic character or stability of carbocation or stability of carbanion because of resonance or hyperconjugation if group is present at meta position. So I will not take resonance, I will take inductive effect only. What about this? This is having minus I as well as minus R, but distance is more, so I will not take inductive effect, I will take minus R. But here, at ortho meta para, only hydrogens are present, and we know when hydrogen is present to carbon-carbon double bond, then it shows no effect. That means it is neutral or normal. First of all, we have to write down minus R. Is there any minus R? Yes, minus R is D. So I will write down D first. Now, after that, minus H, no, minus H is absent. Then minus I is C, so I will write down C. After that, neutral or normal is A, and after that, I will write down this one, plus I is absent, so plus H, so I will write down B. So the answer will be simply DCAB. Acidic character order will be DCAB, but we have to find only the correct order of acidic strength, DCAB. So DCAB is the first option. DCAB is the first option. I hope this is clear to each and everyone there. I hope this is clear to each and everyone there. Come on, let me know quickly. Is this clear? 1 is the right answer. Great. 1 is the right answer. Nice. That is very, very, very good. Now, after this, another question is like this. Amongst the following, the most basic compound is, have a look. First one is this one. First one is this. This is aniline, C6H5NH2. This is option number 1. Then this is option number 2. You have same aniline, but to this aniline, there is NO2 group at para position. Then third option, you have same aniline, and to this aniline there is nitro group present at meta position, and after that you are having this one. This is known as benzyl amine. So what is the difference? These are aryl amines. Nitrogen is directly attached to aromatic ring. This is not aryl amine. This is alkyl amine. already discussed in amines. So this is alkyl amine, or this is already discussed in top 20 concepts of organic chemistry. Have a look. This is alkyl amine, means this lone pair will not take part in resonance. So this is localized lone pair. So this is localized lone pair. What about this? It will take part in resonance, so this is delocalized. It will take part in resonance, hence delocalized. It will take part in resonance, hence delocalized. So we know if nitrogen is having lone pair, either localized or delocalized, remember localized one is more available at nitrogen because it will take part in resonance, hence less available for protonation. This does not take part any resonance, hence more available for protonation. Hence we say simply localized lone pairs are more, available for protonation. Hence such compounds are more basic species. So this will be the right answer. The most basic among these is alkyl amine and instead of aryl amines. Now let me know quickly. Am I clear? Am I clear? Am I clear till now? After this we will be having a question like this. Let me know quickly, is this slide visible to you? Let me know quickly, is this slide visible to each and every one? Let me know, is this slide visible to each and every one there? Is this slide visible to each and every one there? Okay, this is clear. Now, if this is clear, these are all free radicals. These are all free radicals. First free radical here is resonance stabilized by 3 phenyl rings. This is stabilized by 2 phenyl rings, and these are stabilized by hyperconjugation, 9 alpha hydrogens, and this is stabilized by 6 alpha hydrogens. Now, we know these two are resonance stabilized, these two are hyperconjugation stabilized. We know resonance will stabilize carbon free radical more as compared to hyperconjugation. Now we have to find out the increasing order. That means increasing order will be, this will become more stable, then this, then this, then this. That means this is least stable, then this is more stable, more stable, more stable. So order will be like this. So our option will be option number 4. Why is it so? Why is it so? Because this is stable by hyperconjugation, these two by resonance. But hyperconjugation, alpha hydrogen 6, alpha hydrogen 9. That means less stable, more stable. After that, 2 phenyl rings, this is stabilized by 3 phenyl rings. So this is less stable, this is more stable. You have to write down answer in increasing order. I hope this is clear. I hope this is clear. Next question is like this. Next question is like this. But before this, let me know quickly. Let me know quickly, is this visible? Or let me write down this structure. Let me write down this structure. So this is H, what we call C. This is CH, then this is CH2, and this is H, this is HB, and this is HA. You have to tell me, decreasing order of bond energy. Let me tell you, bond energy or bond dissociation energy. Bond energy or bond dissociation energy. These values are actually same, that's why I write down over here or. Otherwise bond energy and bond dissociation energies are different, but values are same. So bond energy or bond dissociation energy, they are inversely proportional to stability. Remember, inversely proportional to stability of carbon free radical formed after cleavage of CH bond homolytically. After cleavage of CH bond homolytically. Now tell me, my dear students, if I broke this CH bond, that means CHA bond, here will be a radical. Yes or no? Have a look. This radical is stabilized due to resonance as well as these 3 alpha hydrogens. That means this hydrogen A, if we remove this or if we break hydrogen A and carbon bond, it will form a carbon free radical which is stabilized by resonance as well as hyperconjugation. Have a look, have a look, have a look, have a look, have a look. If I remove this HB, radical will be formed over here, and this will be stabilized due to only due to hyperconjugation. That means this is not that much stable as this is stable after removing HA, because after removing HA from C, we will form a carbon free radical which is stabilized by resonance as well as hyperconjugation. But if we remove this HB by breaking carbon hydrogen bond, then it will form a carbon free radical which is stable only because of what we call hyperconjugation. But if we remove this one, radical will be present on this, and this radical is neither stabilized by resonance nor by hyperconjugation. Now tell me, that carbon free radical which is formed after cleavage of CH bond, if it is least stable, its bond energy will be more. So which one is least stable after carbon hydrogen bond cleavage? It is this CH bond. This CH bond radical will be least stable. That means C, after that this radical is, say little bit more stable. This is the most stable radical. So what will be the answer? Can I say it is HC, after that it is HB, after that it is HA. HC, HB, HA. So second is the right answer. Let me know quickly, is this clear to each and every one? Let me know quickly, is this clear to each and every one? Let me know quickly. Let me know quickly, is this clear to each and every one? Let me know. Okay, this is clear. So this is clear. This is clear. That's great. Have a look, have a look, have a look. Another question. Another question. Let me draw this question. Let me, say form once again this one. This is first one, this is second one, and tell me, is this clear now? Tell me, is this clear now? Is this clear now? This is second and this is third one. This is third. This is third. And this is fourth. Fourth is clear. Tell me now, are all options clear now? Are all options clear now? Let me know quickly. Are options clear? Are these options clear now? Let me know quickly. Okay, now the question is, which of the following is heterocyclic aromatic compound? That means you have to say which among these is aromatic, but that too should be heterocyclic. Now, this is aromatic, no doubt about that, but this is homocyclic, made up of only carbons. Now have a look, have a look. This does not have complete cyclic conjugation, so hence this can never be an aromatic species. This is not having any, complete cyclic conjugation, so this cannot be an aromatic. This is aromatic, but this is homocyclic. This is having, have a look, this is having complete cyclic conjugation. How? Because this is having, let me write down this over here. Let me show you. This is having p orbital, p orbital, p orbital, p orbital, p orbital, and another p orbital. Let me draw that with the help of another color. Let us suppose like this. So this is having lone pair of electron. Similarly, this is having lone pair of electron, and these are actually like this. Now, can I say these orbitals, this orbital, this orbital, this orbital, not pink one, because pink one is in different plane. So these orbitals are all within the same plane and parallel with respect to each other, and forms, these atoms, the orbitals of these atoms form basically a complete ring. So this is having complete cyclic conjugation. And in these orbitals, how many pi electrons are there? 2, 2, 4, and this lone pair, that means total 6. So this is aromatic with 6 electrons. Hence, this is an aromatic compound with 6 electrons. Hence, we can simply say this is aromatic but heterocyclic. This is aromatic but homocyclic. We have to, draw heterocyclic aromatic species. Now, after this, we will be having another structure. Let me draw these structures once again. Let me draw these structures once again so that these may be much more visible to you. These may be much more visible to you. So this one is benzoic acid, and this one is also benzoic acid. But in this benzoic acid, have a look. In this benzoic acid, there is a substituent present at para position, and that substituent is NO2. Similarly, this is having substituent. This benzoic acid is having substituent nitro but at ortho position. This is having nitro at ortho position. And you have to tell me which one is the most acidic among these. This is also benzoic acid, and this benzoic acid is having OCH3 group, that means methoxy group at para position. Now, let me know quickly what will be the answer. Let me know quickly what will be the answer. Come on. Come on, come on, come on, come on. Let me know quickly. Let me know quickly what will be the answer. Answer should be obviously second because of ortho effect. So due to ortho effect, second becomes the most acidic, what we call compound. After that, we will be having another. But first of all, have a look and tell me, is this slide clear? Is this slide visible to each and every one? Let me know. Let me know. Is this slide clear to each and every one? These are positively charged species. Let me draw this. Let me draw here. These are the positively charged species. Positively charged species. These are positively charged species. And to these positively charged species, OH is there at para position, NH2 is present at para position, and CH3 is present at para position. I'm waiting for your answer quickly, and then Cl is present at para position. And you must know that whenever we are talking about stability of carbocation, such carbocation stability will be explained simply by plus R, plus H, plus I, then neutral, then minus I, then minus H, then minus R. These three should be strong to weak, and these three should be weak to strong. Now have a look. We know OH is basically minus I and plus R group, but I will not take minus I over here as distance is large. This NH2 is also plus R group. This CH3 is showing plus H. I will not take inductive effect of these three. But this is chlorine. Chlorine is halogen. And in halogen, dominating factor is inductive effect. That's why I will take its dominating factor over here, and that is minus I. Now, tell me, first of all, we have to write down plus R. But plus R, that one which is more stronger. We know this is stronger. NH2 shows stronger plus R as compared to OH. So we will write down first stronger and then weaker. That means first it is Q, then it is P. After that, it will be plus H. That means R. That means it is Q, P, R and then S. Q, P, R and then S. It is option number 4. Q, P, R and then S. Now, let me know quickly, is this clear? Ashwin is saying 4, exactly right answer. Exactly right answer. No, 1 is not the right answer. 1 is not the right answer. You have to, say answer question according to this. According to this. Okay, now it's clear. Meena is saying it's clear. Aditya Gopala is saying yes, sir. Okay. Pratyush is saying 4. Ashwin, clear. That's great. That is great. That is great. Now, another option. Have a look and tell me. Tell me, is this clear to each and every one? Is this slide clear to each and every one? Have a look. Have a look. These are negatively charged species now. These are negatively charged species now. These are not positively charged species. These are now negatively charged species. Negatively charged species. Negatively charged species. Now have a look. And here group is NO2. Here group present at para position is CN. At para position group is CH3. Here no group is present at ortho, meta, ya para. So this becomes our neutral group, neutral species. This CH3 at para position becomes plus H. CN at para becomes minus R. NO2 at para becomes minus R. Now, have a look, listen carefully. For stability of negative charged species, stability of Carbanion or negatively charged species, how to find out stability? First minus R, then minus H, then minus I, then neutral, then plus I, then plus H, then plus R. Simple. But these three, strong to weak, These three, weak to strong. Have a look, have a look, have a look, have a look. First of all, we have to write down minus R, but strong one. We know NO2 is strong minus R group as compared to CN. So first it will be P, then it will be Q. Because this is P, this is P, this is Q. So we have to write down P first, then Q, and then have a look, have a look. We have to write down first minus R. So first strong minus R, then weak minus R. After that minus H. Minus H is not present. Then minus I. Minus A is not present. Then N. N is present. So we will write down P, Q, S, and afterwards we will write down R. So P, Q, S, and R. P, Q, S, and R. It's once again fourth option. It's once again fourth option. Exactly, exactly, exactly. Fourth is the right answer. 4 is the right answer. Great. Everyone is giving right answer. That is great. That is great. That is great. After this, we will be having a statement-based question. Question is the acidic strength of monosubstituted nitrophenol. That means either orthonitrophenol, metanitrophenol, or paranitrophenol is higher than, that means orthonitrophenol, metanitrophenol, or paranitrophenol is more acidic than phenol because of electron withdrawing group present in orthonitrophenol, metanitrophenol, or paranitrophenol. Exactly correct statement. Then statement second, orthonitrophenol, metanitrophenol, and paranitrophenol will have same acidic strength. No, that's wrong, because we know paranitrophenol, then orthonitrophenol, then metanitrophenol. This is the acidic strength. They don't have similar acidic strength. That means statement 1 is correct, but statement 2 is incorrect. Statement 1 is correct, statement 2 is incorrect. That means option number 3 is the right answer. Option number 3 is the right answer. Tell me, is this clear to each and every one? Let me know quickly, is this clear to each and every one? Let me know quickly. Let me know quickly, is this clear to each and every one? Let me know quickly. Let me know quickly, is this clear to each and every one? Is this clear to each and every one? Okay, yes sir. After that we will be having this question. After this we will be having another question like this. Let me know, is this slide clear to each and every one? Is this slide clear to each and every one? So that we will answer the question. Is this slide clear to each and every one? Is this slide clear to each and every one? Is this slide clear to each and every one? Okay. Now, question is very, very, very simple, but it can be asked once again. Question can be asked once again from Geldahl's or Doma's method. So be careful. Now, have a look. The question says Geldahl's method for estimation of nitrogen. That means this is used for estimation of nitrogen, and we know that can be used to estimate the amount of nitrogen in which of the following compounds. But remember, for this, whenever Geldahl's method is there, this method can be used to estimate nitrogen or amount of nitrogen from the compounds, but this method is not applicable to compounds in which nitrogen is in the form of, remember, nitrogen is in the form of nitro, it's not applicable. If nitrogen is in the form of azo, it's not applicable. If nitrogen is inside the ring, it's not applicable. Whether that ring is pyridine, whether that ring is quinoline like this, or whether that ring is isoquinoline like this. So whenever nitrogen is present inside the ring, this method cannot be used. If nitrogen is in the form of nitro, this cannot be used. If this nitrogen is present in the form of N double bond N or N triple bond N, I mean say azo, then it cannot be used. So this and this, these compounds, I mean say for these compounds, Geldahl's method is not applicable or not used. Now the question is for which it can be used. Then it seems to be only option number 4. So this compound is the compound whose estimation of nitrogen can be find out with the help of, I mean to say, Geldahl's method. So have a look. Is this clear? Is this clear, my dear students? Is this clear? Tell me, is this clear? Am I clear till now? Quickly, quickly, quickly. And let me tell you that you will see your paper on 3rd May, and you will yourself judge how paper was. Was that paper from our sessions or not? You will see that on 3rd May. Now, after this, we will be having another question like this. We will be having another question like this. Look towards the question and tell me the answer. And tell me the answer. Question is from Isomerism. Come on. Tell me the answer. Tell me the answer. Very, very, very simple question. One, this is carbon. Then here it is what we call a dash bond with hydrogen. This is the dash bond with hydrogen. That means hydrogen is considered behind the plane. Then normal bonds are with bromine and CH3. That means bromine and CH3 are present on the plane. And this chlorine is showing wedge bond. That means this chlorine is present above the plane. Chlorine is present above the plane. Now, we have to say what is the, we know this is the chiral center, as this is sp3 hybridized and is having 4 different groups attached to it. So this is what we call a chiral center. So we know bromine is having higher atomic number than chlorine, then this carbon, and lastly this hydrogen. As hydrogen is already present on dash bond, that means behind the plane. Now check only 1, 2 and 3. Can I write down 1, 2 and 3? They are like this. 1 is here, then this is carbon, 1 is here, then after that 2 is here and 3 is here. Let us suppose in this direction, 1, 2, 3. So can I say it's clockwise? Clockwise means R, hence it is R. So the configuration of this chiral center is simply R. Now, is this clear? Is this clear, my dear lovely students? Is this clear? After this, we will be having question. Have a look and tell me, is this clear? Is this clear? Is this clear? But before that, let me arrange this slide in this fashion, little bit towards right, so that this becomes much more visible to each and every one. Oh ho 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 ho. Okay. 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 After this, we will be having another question. Let me know in the chats what will be the answer. But first of all, is this clear? But first of all, is this clear to each and every one? Is this slide clear to each and every one? Is this slide clear to each and every one? Is this slide clear to each and every one? Come on. Come on, let me know quickly. Come on, let me know quickly. Is this slide clear to each and every one? Is this slide clear to each and every one? Tell me. Yes, sir. So what will be the answer? As you know, this is simply hydroboration oxidation. This is simply hydroboration oxidation. This is hydroboration oxidation. Whenever you are having this, you have to add water. You have to add water according to anti-Markovnikov's rule. And remember, addition of water, that means H and OH should be added. H and OH should be added from same side, because this is syn addition reaction. Should be added from the same side, as this is syn addition reaction. Have a look. That means if we talk about this compound, here carbon-carbon double bond is there. This carbon is not having any hydrogen, but this carbon is having one hydrogen. This carbon is having at least one hydrogen. So we know negative part of water means OH should go to that carbon-carbon double bond which is having more number of hydrogen. That is what we call anti-Markovnikov's rule. So negative part, that means OH should go here and H should go here. Yes or no? But OH and H should go to these places. But H and OH should be on same side. That means if H is below the plane, OH should also be below the plane. That means H and OH should be on same side. Here, H is below the plane, But OH is not below the plane, that is opposite to that of H. This is above the plane. But we know H and OH must be present on the same side because this is syn addition reaction. So what will be the option? What will be our answer? Our answer should be only 2. Is this clear? Is this clear? Is this clear? Is this clear, my dear lovely student? Is this clear? Okay. Is this clear? Quick. Let me know. Let me know quickly. Is this clear? Is this clear? Okay, clear. That is great. Next question is like this. Tell me. What will be the answer? Quickly. This is hydroboration. After this question is from oxymercuration, demercuration. But before that, is this visible? Is this slide visible? Is this slide visible to each and every one? Is this slide visible to each and every one? Okay. Okay, this is clear. Okay, that's great. Now, as we know, this is hydroboration, this is oxymercuration, demercuration. Here we have to add water across carbon-carbon double bond, across this carbon-carbon double bond. But now, according to Markovnikov's rule, that means negative part of water, that means OH, goes to that carbon-carbon double bond which is having lesser number of hydrogen. That means OH should go here. That means option number first is the right answer. Option number first is the right answer. Now, let me know quickly. Is this clear? Let me know quickly. Is this clear? Is this clear, my dear lovely students? Is this clear? Yes, one is exactly the correct answer. Mubina. At the rate of Mubina. Exactly right answer. Okay. At the rate of Vishnu. Okay, thank you. At the rate of Aditya Gopala. Yes, thank you. At the rate of Shafkat. Thank you. Ashwin. Thank you. Kanmani. Thank you. At the rate of Sudhar. Exactly, thank you. At the rate of Gangadhar. Thank you. At the rate of Meena. Thank you. God bless you all. God bless you all. God bless you all. Okay. Then we have another question like this. The reaction ethene plus Br2 gives CH2Br, CH2Br. That means vicinal dibromide. Now, this is a very simple question because there might be few questions which are very simple in your NEET examinations. Only 2 to 4 questions will be there in which you have to sort of think what will be the answer and which type of question is this. Otherwise, other 12 to 13 questions will be very easy. Now, let me know the answer quickly. This is an example of, do you know, whenever alkene and halogens are there, whenever halogenation of alkene takes place, it's electrophilic addition reaction, and that electrophilic addition reaction which takes place via non-classical carbocation. But it's saying, is this nucleophilic addition, electrophilic addition, elimination, nucleophilic substitution? It is simply electrophilic addition reaction. After this, another question, Bayer's reagent. What is Bayer's reagent? It's called dilute alkaline aqueous KMnO4 solution. So it's called dilute alkaline permanganate solution. Called dilute acidified? No. Neutral permanganate? No. Aqueous bromine? No. It is called dilute alkaline permanganate solution. After that, we will be having increasing order of reactivity towards ESR for the following species. Now, you must know that reactivity towards ESR or rate of ESR, remember, it is directly proportional to electron density. It is directly proportional to electron density of the ring. Say aromatic ring. Electron density of the aromatic ring. More electron rich is the aromatic ring, more faster will be the, electrophilic substitution reaction. Now, tell me, in these four, benzene ring is attached to OCH3, benzene ring is attached to Cl, benzene ring is attached to NO2, benzene ring is attached to CH3. What will these groups do to the benzene? Have a look. This will, this OCH3 will donate electron towards benzene because of a phenomenon known as plus R. Cl will withdraw electron because of minus I, because its inductive effect is more powerful than resonance. NO2 will withdraw electrons, withdraw electrons away from benzene ring because of minus R. CH3 will donate its electron towards ring because of plus I or hyperconjugation. So in nutshell, this is electron donating, these two are withdrawing, this is donating. But this is donating due to resonance, so it will increase electron density of ring more as compared to this one. That means electron density of ring will be more in first, then 4, then it will be 2, then it will be 3. That means least, reactive towards ESR will be 3, after that it will be 2. 3, after that it will be 2, after that it will be 4, and highest reactivity should be of, 1. So this will be the answer. Now let me know, is this clear? Let me know, is this clear? Let me know, is this clear? So this is the least reactive. After that this one. After that it will be 4 and 1 will be the highest reactive. 1 will be the highest reactive. 1 will be the highest reactive. Okay, exactly. After this, we will be having another. During nitration of benzene, attacking electrophile is NO3 minus, no. NO2 minus, no. It is NO2 positive, exactly. And this will be nitronium ion. That means during nitration, nitronium ion will act as an electrophile. You must know that electrophile of the reaction during nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, halogenation, you must know what are the electrophiles, or what is the electrophile during carbylamine reaction, what is the electrophile of what we call Kolbe's reaction, what is the electrophile of Reimer-Tiemann reaction. You must know each and everything. Now, after this, the appropriate reagent for the transformation is, have a look. This is the compound in which you have to convert this C double bond O to CH2. Here C double bond O has been converted to CH2. But first of all, let me know, is this clear? Yes, this is clear. Now, you have to say that which among these are the reagents. Have a look. It is C double bond O of ketone. We know C double bond O of aldehyde or ketone is converted to CH2 with the help of either Clemmensen reduction, Wolff-Kishner reduction, or with the help of reducing agent like HI. But if we use NaBH4, it will convert C double bond O to CHOH, that means alcohol. If we use H2Ni, that will convert C double bond O to alcohol. That clearly indicates that NaBH4 cannot be the option, H2Ni cannot be the option. Either it is what we call zinc amalgam HCl, that means Clemmensen reduction, or NH2NH2OH minus, that means Wolff-Kishner reduction. But in acidic medium, this OH can react with acid and it will leave, and instead of OH, there will be Cl. But in this, OH is not affected. But if we take this ketone in acidic medium, this is acid sensitive. As it is acid sensitive, it will simply remove OH as well. But in this transformation, then in this conversion, there is no, replacement of OH. That clearly indicates we have not used acidic medium, we have used basic medium. Hence, the right answer is Wolff-Kishner reduction. Hydrazine in presence of basic medium is the right option. After this, we have another question. Now, before that, tell me, is this clear to each and everyone? Is this slide visible to everyone? Is this slide visible to everyone? Is this slide visible to each and everyone among you? If it is visible, tell me the answer, because this is words reaction. This is very, very simple. This is words reaction. Very, very, very simple. Very simple. Very simple. Come on. Come on. This is very simple. It's words reaction. Very simple. Very simple reaction. Now, we know whenever alkyl halide, whenever CX bond is there and sodium is there, we have to break this and we will form a radical like this. Now, after this, this will combine with similar radical and will result in the formation of this product. So, this will be the product of this reaction. So, option number 2 is the right answer. Option number 2 is the right answer. Is this clear? Is this clear? No, Rufi, it's not 1. It's not 1. It's not 1. It is option number 2. It's option number 2, not 1. At the rate of Kushal, it's not 1. It's not 1. How come? How come it should be 1? Because it is CH3CH, Cl. CH will remove, so isopropyl radical will be formed. When isopropyl radical forms, then it will combine with another isopropyl radical and results in the formation of 2,3-dimethyl-butane. Is this clear? Is this clear? Okay, that's clear now. That's clear now. After this, we will be having another question. Have a look and tell me the answer. This is very, 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 very simple. Tell me the answer. Because organic chemistry is very simple, provided you have clear concepts. Now, tell me the answer. Tell me the answer. This is alkyne. On treatment with sodium in ammonia, that means this is what we call Birch reduction. Birch reduction. During Birch reduction, it gives an alkene, but trans alkene. So A should be trans. A should be trans. A should be trans. A should be trans. I hope this is clear. But this is Lindlar's catalyst. That means H2 in presence of PDBaSO4, PDBaSO4 plus sulfur or quinoline, or H2PDC, or H2 what we call PD plus CaCO3 plus sulfur plus quinoline. So any reagent can be used, P2 catalyst can be used. That means nickel boride can be used, then this becomes cis. So A is trans, B is cis. A is trans, B is cis alkene. So this is the right answer. A is trans, B is cis. Now this is the right option. Exactly, first is the right option. After that, we will be having another question. We will be having another question. We will be having another question. Have a look and tell me the answer. Quick. Come on. Because with the help of these questions, your concepts will be revised. Come on. This is very easy. This is halogenation of alkene. Halogenation of alkene, remember, is anti-addition reaction. It's anti-addition reaction due to formation of cyclic bromonium ion. Because this reaction takes place via cyclic bromonium ion, cyclic halonium ion. I mean, say, non-classical carbocation. So this is anti-addition reaction. That means one bromine and another bromine, that means should be added from opposite sides. That means if one bromine is added above the plane, another should be below the plane. So its answer should be like this. Its answer should be option number 2. Exactly 2 is the right answer. Exactly 2 is the right answer, my dear lovely student. 2 is the right answer. Ashwin is correct and Rufizan is correct. Okay, Ponce, you can use Lindlar's catalyst, you can use P2 catalyst, nickel boride catalyst, or you can say, you can use simply what we call Rosenmund's catalyst over here. Whether you use Rosenmund's catalyst, whether you use Lindlar's catalyst, whether you use what we call P2 catalyst, that is known as nickel boride catalyst. At that time, alkyne forms alkene, but cis alkene. We have already discussed these things in hydrocarbon chapter. You can go through hydrocarbon so that will help you. Our another question is, tell me, what will be the answer? What will be the answer? Quickly. What will be the answer? Come on. Quickly, my dear lovely students. Quickly. What will be the answer? What will be the answer? I am waiting. I am waiting. What will be the answer? What will be the answer? Is anyone knows the answer? Okay. At the rate of Irfan, sir, I have truly started loving your lectures. Throughout, our previous teacher was best, but now I feel your teaching is even better. Thank you very much. At the rate of Irfan, God bless you. Thank you very much. Now, have a look. Now, first of all, it is like this: CH3, then it is C, then it is triple bond CH. When this is treated with CH3 MgBr, CH3 MgBr, can I say CH3MgBr is having partial negative, partial positive charge. That means now we know this is the terminal alkyne and this hydrogen is an acidic hydrogen. This hydrogen will be abstracted by this CH3 and it will result in the formation of CH4. Then what is this? Both electrons will be present on this carbon, so it will become CH3C triple bond C having negative charge, and MgBr will be attracted to that negative charge. So first of all, it will become this and methane. After that, it reacts with CH3, CH2 and then Br. This will act as a nucleophile. It will attack electron deficient site and Br will be lost. So Br minus MgBr results in the formation of MgBr2. MgBr2. So what will be the structure of this? It will be CH3, C, triple bond C. C forms a bond with CH2. And then this CH2 forms bond with CH3. So this is the product. This is the product. So 1, 2, 3, 4, 5. That means it is pent but 2-ion. Is there any pent 2-ion? Is pent 2-ion any structure? Pent 2-ion? Pent 2-ion? Yes, this is the pent 2-ion. 1, 2, 3, 4, 5. Pent 2-ion is the structure. Now tell me, is this clear? Now tell me, is this clear? Is this clear? Option number 2, exactly option number 2 is the right answer. Great. That is great. That is great. That is great. I'm very much happy that many students are basically with me. Many students among you are basically with me. They are not only chatting with each other. They are actually with me in the session. Ansh Thomer, sir, you have so much experience and thanks. Yeah, I have very much experience. I am in this field more than 20 years. I have taught millions of students. Thank you and God bless you. So don't worry. That's why I'm very much sure that your questions will come in your NEET examinations from these sessions only. So God bless you all. Don't worry about that. Have a look. Have a look. Another question is like this. Is this slide clear to each and everyone? Is this slide clear to each and everyone? Is this slide clear to each and everyone? Let me know in the chats quickly. Let me know in the chats quickly. Yes, this is clear. Yes, this is clear. Now, the question says, a single compound of the structure is given, is obtainable from ozonolysis of which of the following compounds cyclic compound? Now, whenever you are given with, say the product during ozonolysis, then you just simply do one thing. O and O, double bond O and double bond O. Make the structure in such a way, say for example, this C double bond O, then this C is having H, this C is having H, then this C double bond O. Form in such a way that O and O comes closer to each other. Now, after that, this C double bond O is having CH3. Let us suppose this is having CH3. Now, in between this C double bond O and this C double bond O, there are CH2, CH, CH2. 3 carbons are there. 3 carbons are there like this. CH2, then it is CH. At CH, one is having CH3 group, and then to this it's having CH2, and then it's having CHO. This is, say that structure. Why I have written in this fashion? So that we can remove these 2 oxygens and will form double bond. When we form double bond over here, so structure will become like this. Have a look. Here it will become CH3. Here it will become CH3. That means one CH3 is present at double bond and another CH3 is present at alternate position with respect to that. Now, is there any structure which resembles like this? Have a look. This is, say double bond having CH3, double bond having CH3, and after that 1, 2 and 3, say alternate position. So this is the right option. This is the right option. Exactly. 4th is the right option. Everyone is saying 4. Yes. Acha, okay, it's only Kingy King. Okay. Kingy King is saying 4. Rufizan is saying 4. Exactly. Meena is saying 4. Nice. That's good. God bless you. God bless you. After that, we will be having another question. The reactivities of CH3Cl. Let me write down over here. Reactivity of CH3Cl. Number 1. Number 2 is CH3, CH2, CH2, and then Cl. And number 3 is chlorobenzene. It's like this. You have to tell me the reactivity order towards SN2. We know those compounds in which pi bond is present at alpha position, with respect to leaving group, they do not show SN2 reaction at all, like aryl halide. Why is it so? Because nucleophile has to attack this position, as this is already electron rich. This electron rich position or electron cloud above and below the plane will repel incoming nucleophile. One reason. Another reason is, for nucleophilic substitution we have to break CCl bond, but this CCl bond is very strong because of partial double bond character as a result of resonance. So this is difficult to cleave. So it will not show SN2 at all, or its SN2 reaction will be very less. After that, this is, say alkyl halide, primary alkyl halide. This is also primary alkyl halide, but in this primary alkyl halide, this alpha carbon is having only hydrogen, but this alpha carbon is having one alkyl group. We know more the number of alkyl group at alpha or beta position, lesser will be the rate of SN2 because of steric crowding or steric repulsion. So can I say CH3Cl will show faster, say what we call SN2 reaction, after that CH3, CH2, CH2Cl, and lastly it will be C6H5Cl. So our answer will be option number 1. Exactly, option number 1 is the right answer. After that, we will be having another question. Which of the following is maximum reactive towards SN1? Let me tell you that rate of SN1 is directly proportional to stability of carbocation. It is directly proportional to stability of carbocation. Now, you can form carbocation at every place and tell me the answer. I am waiting for your answer. I am waiting for your answer. Come on. I am waiting for your answer. I am waiting for your answer. Have a look. Its carbocation will be like this. Its carbocation will be like this. And whenever carbocation is present on phenyl ring, it is stabilized only and only by inductive effect. That means it's not stabilized by resonance, it's not stabilized by hyperconjugation, only and only by inductive effect. And its inductive effect in all these cases will be, say its inductive effect is plus I, but it will be weaker because it's present at a larger distance. It shows minus I, it destabilizes the carbocation. It shows minus I, it destabilizes the carbocation. That means only this can stabilize a little bit carbocation with the help of plus I. But if you form carbocation of this, its carbocation is stabilized by 3 methyl plus I groups plus 9 alpha hydrogens. So this is the say alkyl halide, or this is the substrate, this is the compound which forms most stable carbocation. Hence its reactivity towards SN1 will be highest. Its reactivity towards SN1 will be highest. Yes, exactly. Exactly. Yes, lighting issue will be solved within few days, because I am preparing another studio for me, so don't worry about that. But first of all, just try to understand right now. Okay, now that's great. After that, we will be having another question. Look towards this question. If I switch some lights, let me know, will there be any clarity? Is this clear? Now, have a look. First of all, we will be having CH3, CH2, CH, double bond CH2. Then question is saying this is X. Now, this X upon treatment with HBr and peroxide gives, we know in presence of peroxide, we have to add HBr according to Anti-Markovnikov's rule. So it will be like this. So it will be like this. Br will go to that carbon-carbon double bond which is having more hydrogen. That means this one. So this is Ry. And this upon treatment with C2H5O minus Na positive, that means ethoxide ion, sodium ethoxide. Now this is simply an SN2 reaction, Williamson's ether synthesis. It will attack this carbon and this bromine will be lost. Then it will become CH3, CH2, then CH2, then once again is CH2, that means 3 CH2, and then it is O, then it is CH2, C2H5. That means CH3, CH2, 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 then OC2H5. Then it is this one. CH3 1, then CH2 whole 3. That means 1, 2 and 3. Yes, this is the answer. This is the answer. Let me know, is this clear? Let me know. Let me know, is this clear? Let me know, is this clear? Let me know, is this clear? I have switched this light. Now tell me. Now tell me. As I have decreased the, the intensity of light. Now is this clear now? Is this clear now? Am I clear now? Am I clear now? Am I clear? Is this board visible now more properly? Let me know, is this board clear now more properly? At the rate of universe of Minecraft, please, I have many doubts. Yes, beta. Whatever you have, tell me. Okay, you want to repeat, and you want me to repeat this question once again. Have a look, have a look, have a look. Whenever we add HBr in presence of, say peroxide to unsymmetrical alkene, it is anti-Markovnikov's addition. That means negative part of HBr goes to that carbon-carbon double bond which is having more number of hydrogen. So Br goes to this and H goes to this. So it is this. After that, this ethoxide C2H5O minus will act as a nucleophile. It will attack electron deficient carbon. Bromine will be lost. So instead of bromine, it is OC2H5 which goes to this carbon. So it is CH3, CH2, CH2, CH2. Then it forms bond with this OC2H5. So it is this. Now, is this clear? Am I clear? Am I clear now? Okay, after this, we have another question. We have another question. Question is like, this is NaI. This is I over here. This is also I. Okay, in Finkelstein reaction, which reagent is used? It is obviously NaI and acetone. It is NaI and acetone, that means it is fourth one. It is fourth one. It is fourth one. After that, another question. C2H5Cl plus AgF in presence of water gives C2H5F and it. Okay, the above reaction is, remember, whenever you are having alkyl chloride or alkyl bromide and chlorine or bromine will be replaced by fluorine of heavy metals, this is known as Schwarz process. This is simply halogen exchange reaction. So it is Schwarz process. Exactly. After that, thank you, beta. At the rate of universe of Minecraft is saying, love you, sir, love you more, love you more. So that is so delayed. Please fix it. Okay. Now, is this clear now? After that, we will be having this structure. Let me help over here. Structure is like, it is CH3, then it is CH, then it is CH, then it is having CH2. That means an unsymmetrical alkene is there. You have to add HBr. You have to add HBr and product will become A. You have to tell me what is A. You have to tell me what is A. A predominantly is. So what is A? What is A? Option number 1. A is CH3C, CH2, CH3. Here it is Br and here it is CH3. This is A, first option. Second option is CH3, CH, here it is Br, then it is CH3, then it is CH, then it is CH3. Third option is like CH3CH, CH, CH3, Br, CH3. And your fourth option is like this: CH3CH, CH3, then it is CH2, then it is CH2, then it is Br. Now tell me, what will be the answer? What will be the answer? Have a look. Let me write down same question over here. Let me write down same question over here. What will happen? First of all, H will be added so that a carbocation which is more stable over here will form like this. After that, we have to shift this hydride, that means 1,2 hydride shift will be there, so that more stable carbocation will be formed. So this is the carbocation which is formed finally after rearrangement. Then Br minus will attack to this position, and we will get CH3C, CH3. Here it will be Br, here it will be CH2, and then CH3. So 2-bromo-2-methyl-butane will be the answer. 2-bromo-2-methyl-butane will be the answer. That means our option number first is the right answer. Exactly. So don't worry, we will manage this light issue because you are serving. Okay. Thank you very much. Thank you very much. It means a lot. It means a lot. So, after this, someone is saying love from Kupwara, love from Srinagar as well. So, love you more. Thank you. God bless you. Okay, after this, we have another question. Another question is like this. 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 This is clear. I think this is clear. Now, this is what we call 2,4,6-trinitrochlorobenzene is there. On treatment with water and only on warming, it results in the formation of, it is simply picric acid will be obtained. 2,4,6-trinitrophenol, picric acid will be obtained. This is very easy and it is an example of NCERT directly. Now, after this, we will be having another question. Question is like this. It is CH3CH2Cl. I'm also watching, is slide clear or not? But you have to be very much vigilant there. You have to tell me, is this clear or not? You have to tell me, is this clear or not? You have to tell me, is this clear or not? Okay, let me try to draw it once again. This is ethyl chloride. This upon treatment with NaCN. This upon treatment with NaCN gives A, and upon treatment with AgCN gives B. You have to tell me what is A and B. A and B will be respectively. A and B will be respectively. You have to tell me A and B respectively. First option is that A is this one and B is isocyanide like this. Similarly, option number second is that A is isocyanide and B is cyanide. Very easy question. After that, it's a nucleophilic substitution reaction of, alkanes. First is this one and second is this one. Both are cyanides. And fourth option is both are isocyanides. You know what is the difference between, I mean to say, this NaCN and AgCN. NaCN, we know NaCN is an ionic compound. It is an ionic compound. And here Cn having a negative charge is the nucleophile. And we know this is an ambidentate nucleophile or ambident nucleophile because of two different donor sites. Nitrogen can also simply attack this carbon and will replace Cl, but that will form N-C bond, which is weaker. Carbon can attack, but carbon can form C-C bond, which is more stronger. So carbon will attack more. That means major product will be cyanide from this. And here, this is a covalent compound. Nitrogen will attack and major compound will be NC. So first A will be cyanide and B will be isocyanide. So first option is the right option. Tell me, is this clear now? Tell me, is this clear? Exactly, this is clear to each and every one. Okay, but let me write down, this was third option. And this was option number 4. After this, let me put on light once again because it's not because of light. Now, tell me, is this slide clear? Is this slide clear? Is this slide clear? This is magnesium. This is magnesium in presence of Et2. I mean, say diethyl ether is the solvent. After that, it is H2O, this one. Hi sir, my name is Ria. I am in Kerala, but I can watch all your live classes. It's very useful to me. Thank you so much, sir. Thank you, beta. Thank you. God bless you. God bless you, Ria. God bless you. Sorry, Rini, at the rate of Rini. God bless you. God bless you. And your name is Ria. Yes. God bless you, beta. God bless you. Now, after this, have a look. You are having chlorobenzene. Have a look. You are having chlorobenzene. You are having chlorobenzene. You are having chlorobenzene. On treatment with magnesium, remember, whenever CX bond is there and magnesium is there in presence of, say, for example, ether, then magnesium comes in between C and X. So it will result in the formation of this one, phenyl magnesium chloride. This is Grignard's reagent, and in Grignard's reagent, this C is having negative part and this Mg is having a positive part. After that, when this Grignard reagent is treated with H2O, H2O is acidic hydrogen containing compound. That means it can donate H positive, and that H positive will be accepted by this negative part. That means this negative part will act as base. It will abstract H. So it will result in the formation of benzene. It will result in the formation of benzene because it accepts this H, plus it is after that Mg, to which Cl and OH will be attached. So what is the answer? Answer is benzene. Here, answer is benzene. Is this clear? Is this clear? Is this clear? सर आप श्रीनगर में पढ़ाते हो ऑफलाइन, आपको लेजेंड टीचर हो, अल्लाह आपको सलामत रखे. Thank you beta, thank you beta, thank you, God bless you, God bless you. Okay, now after this, we will be having another question. Have a look towards this question and tell me what will be the answer of this question. Come on. Let me know quickly. What should be the answer of this question? Let me write down over here. It's NBS. NBS means N-bromosuccinimide in presence of light. And product is A. When this cyclohexene is treated with NBS, product is A. Then this product upon treatment with CH3, then C, then triple bond C having negative charge, and then Na positive, results in the formation of B. we have to tell what are products A and B. What are products A and B? Now, let me help you over here. Reaction is actually like this. This upon treatment with NBS, and we know NBS, N-bromosuccinimide, will do, say allylic bromination, whether to this position or to this position, because these are the allylic positions. Now, what will happen over here? Allylic halogenation, allylic bromination will take place. So first of all, it will result in the formation of allylic bromide like this. Then this upon treatment with CH3, then C, then triple bond C, then having negative charge, Na positive. So this is A. Now this A upon treatment with this C will attack, this will act as a nucleophile, and Br will be lost. So we will get like this. Here it will be C. After that, this C is attached to C with a triple bond, and then this is attached to CH3. Na positive, Br minus, that means NaBr will be lost. And this is Rb. So we have to write down the answer, what is A and what is B. Now, can you write down the answer, which type of, option is the right option? So these are A and B are. So this is here Br, and without, double bond. That means this is bromocyclohexane, and it is this one, C triple bond CH. So this can never be an option. Our second option is like this. Here it is Br, and in our this is in second option, B is C and Me. Me means methyl, methyl means CH3. That means this is the right option. This is the right option. So this is the right option. Now tell me, is this clear? Third option is like this. It is CH2 over here, and then it is C triple bond C, then Na. So this is not the option. Okay, this is not the option. Our second option is the correct answer. Second option is the correct answer. Now let me know quickly. Am I clear till now? Am I clear till now? Fourth option is visible. Fourth option is visible. So let me know quickly. Let me know. Achha, what is NBS? Okay, you don't know what is NBS. NBS is a reagent which is used for either allylic halogenation, known as allylic bromination, or benzylic bromination. NBS means N-bromosuccinimide. Let me write down over here its structure. NBS is this one. NBS is this one. This is NBS. If NCS is sometimes written, that is N-chlorosuccinimide. This is N-bromosuccinimide. When it is N-chlorosuccinimide, then you have to write down chlorine instead of bromine. I hope this is clear. 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 Okay, after this, another question is like this. Is this clear? Is this visible? Is this visible or not? Let me know quickly, is this visible or not? Is this visible or not? Yes, this is visible, I think so. I think this is visible. This is visible. Now have a look, have a look. This is Cl. Cl is having lone pair of electron, we know. Similarly, this Cl is having lone pair of electron. This Cl is having lone pair of electron. Now, it's AgNO3, that means it is Ag positive NO3 minus. So whenever Ag positive and Cl minus results in the formation of AgCl, white precipitate will be obtained. Now question is, which will give white precipitate with AgNO3? That means which among these can break this bond so that it can result in the formation of AgCl. Cl minus and Ag will react and form AgCl. Have a look. When this bond is broken, it results in the formation of a carbocation, and this carbocation is stable because of resonance. Similarly, if we try to break this bond, suppose we try to break this bond, this is highly unstable carbocation, so it cannot be formed. That means this bond is difficult to break. Second, have a look. Second, this bond is very strong bond due to partial double bond character. Hence, it will not be cleaved because this is strong bond due to partial double bond character as a result of resonance. After that, this bond can be easily cleaved because it can result in the formation of a carbocation which is resonance stabilized. That means more stable carbocations. This is more stable, but this is less stable. So whenever after cleavage of CCl bond, you can form more stable carbocation, then CCl bond is easy to break. Now tell me, whose CCl bond is easy to break? It is 1 and 3. That means both 1 and 3 can easily break, say CCl bond. That means Cl minus can be what we call departed in 1 and 3 easily. Then AgCl, that means white precipitate, will be formed from 1 and 3. That means option number 4 is the right answer. Tell me, is this clear? Is this clear? Is this clear? Come on, my dear lovely students, come on. Be with me, be with me, be with me. Come on. We have another structure. And structure is like, let me write down over here. What is the reaction actually? So that there will be no need of this slide. Have a look. We will be having HC triple bond CH. This on treatment with, number 1. NaNH2 in presence of liquid ammonia. That means ammonia here is acting as salt. But NaNH2 is sodamide, a strong base. What will happen? What will this strong base do? It will abstract this H, and NH2H positive, that means ammonia will be lost, and it will result in the formation of HC triple bond C having a negative charge, and to this negative charge Na positive will be attracted. After this, second reagent is CH3CH2Br. Now what will happen? This will act as a nucleophile, will attack this electron deficient site, and Br will be lost. So Na positive Br minus NaBr will be lost, and we will get HC, then triple bond C. C can form bond with CH2, and then CH2 is attached to CH3. So this is our X. So this is question number 1. That means if you treat this with NaNH2 and liquid ammonia, then you treat that product with CH3CH2Br, then what will be the product? What will be the product formed over here if that product is X? What will be X? Can I say X is this one? That means but1-ine. Is there any option but1-ine? Yes, either 1 or 4. 1 or 4 can be our option. It can never be, say 2 or 3. Now after that, this X is treated with, once again, X is treated with NaNH2 once again in presence of liquid ammonia. That means ammonia is the solvent. After that, product will be formed. Then that product is treated once again with CH3CH2Br. That means similar type of reagents are there, and it will result in the formation of Y. Now what is Y? Have a look. This X is now treated with NaNH2 in liquid ammonia once again. What will happen? This is positive, this is negative. It will act as a base and will abstract this hydrogen. So NH2 will abstract this H, ammonia will be lost. Then this becomes C triple bond C, single bond CH2, single bond CH3. This will be having a negative charge, and Na positive will be attracted to that. After that, finally, this is treated with CH3, CH2 and Br. What will happen? It will act as a nucleophile, will attack to this carbon to which leaving group Br is attached. So Na positive Br minus will be lost in the form of NaBr. Then this is C triple bond C, CH2, CH3. Now to this C, it is CH2 and CH3 which will be attached. So this is what we call Y. We have to tell what is X and what is Y. X is but1-ine and Y is 1, 2, 3, 4, 5, 6. That means hex 3-ine. Hex 3-ine or 3-hexyne. But1-ine and hex 3-ine. That means option number 1 is the right answer. Option number 1 is the right answer. Tell me clearly. Tell me quickly. Is this clear till now? Am I clear till now? If this is clear till now, show some green hearts in the chats. Quick. Show some Josh in the chats as well. Quick. Quick. Come on. Come on. Come on. Come on. Show some Josh in the chats. Because Josh is not now high. Josh was high. Now Josh is not high. Come on. Show some green hearts. Show some, I mean to say, fire emojis as well. Thank you. Thank you. Thank you. Thank you. Thank you. Great, 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 great. God bless you all. God bless you all. That's great. That is great. That is great. After this, we will be having another reaction. Another question. Identify the major product C formed in the following reaction sequence. There is a reaction sequence given which is not that much clear. So let me write down once again. It is CH3, then it is CH2, then it is CH2, then it is I. This on treatment with NaCN. Simple nucleophilic substitution reaction will be there. So I will be replaced by CN. I will be replaced, this is I will be replaced by CN. After that, it is treated with OH minus, I mean say in presence of base, partial hydrolysis take place. That means hydrolysis of cyanide, but partial hydrolysis of cyanide. We know partial hydrolysis of cyanide will give amide. That means this is amide CONH2. Then this amide on treatment with NaOH Br2. That means this is Hoffman bromamide degradation reaction gives C. So C is amine. C is amine without or amine less, having one carbon less as compared to B. So have a look what is basically this reaction. This is CH3, CH2, then CH2, then I. When treated with NaCN, product will be CH3, CH2, CH2, then it is C triple bond N. I mean say instead of I, we have to replace I by cyanide. After that, partial hydrolysis of cyanide gives partial hydrolysis of cyanide. Remember, it results in the formation of amide. That means CONH2. Now this upon treatment with NaOH Br2, that means this is Hoffman degradation reaction. Just remove this C double bond O. We will get CH3, CH2, CH2, NH2. So this is propyl amine. So propyl amine is the answer. So option number 3 is the right answer. Now let me know quickly, am I clear till now? Let me know quickly, am I clear till now? Come on. Come on, come on, come on. Your Josh should be very much high. Come on. Because you are practicing basically organic chemistry. Your whole organic chemistry will be revised with the help of these questions. Come on, tell me. Okay, after that, another question is, the given reaction is called as, this is ethoxide and this is alkyl halide. Reaction of ethoxide with alkyl halide resulting in the formation of ether is known as Williamson synthesis or Williamson ether synthesis. So it is simply Williamson's ether synthesis. After that, next question. The product of the reaction, this is alcohol and this is copper, and that too, this alcohol is primary alcohol. Whenever primary alcohol is heated with copper or treated with hot copper, it undergoes dehydrogenation and results in the formation of aldehyde. You should remember that. So the product is, I mean say, aldehyde. After that, another question is, consider the following transformation. Can you tell me the answer of this question, as this question is very, 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 very good question. I like this question basically. Now tell me the answer of this question. I want to see how many among you can tell me the right answer. Let me see how many among you can tell me the right answer. Come on. Come on, come on, come on. Tell me the right answer. Come on, tell me the right answer. Come on. Come on, you can tell me the right answer to this question. I'm waiting. I'm waiting. Come on, your Josh should be very much high. And this is the reaction which is asked in NEET now and then. So this is very, very, very important. I mean, say reaction. Have a look. Somebody is saying 3, someone is saying 1, someone is saying 2, 1, 1, 1, 1, 1. Have a look, have a look. This is actually a reaction like this. Whenever you are having an unsymmetrical ether, aliphatic unsymmetrical ether, and if neither this group nor this group is tertiary, then at that time, on treatment with concentrated Hi or Hi at high temperature 373 Kelvin, reaction becomes an example of SN2. And when reaction becomes an example of SN2, our I minus should go to that carbon-carbon double bond, say alkylic part, which is basically smaller in size. But in this case, we will not say like that. We will simply say that if I minus goes to this, then H goes to this oxygen. That means we have to break this bond. But if I goes to this, we have to break this bond. But this bond is difficult to break because of partial double bond character as a result of resonance. So I will break this. So I will go to this, H will go to this. So product will be like this: CH3, CH, double bond CH, single bond OH. Plus it will become ICH2, CH3. But remember, this is known as enol. And you know, in case of enol, there can be tautomerization. Why? Because this enol is less stable as compared to its keto. So it will form more stable product, and that is its keto. And that keto is CH2, C, then it is double bond O, and then H. So it is CH3, CH2, CHO. CH3, CH2, CHO will be one product. CH3, CH2I will be another product. So CH3, CH2, CHO and CH3, CH2I will be another product. That means option number first is the right answer. Let me know quickly. Is this clear? Yes. Yes, Rufizan, 1 is the right answer. Exactly. So otherwise, if it is not enol, then this alcohol will be the product. But if Hi is in excess, then alcohol can be converted to alkyl iodide. You know that. No, Ashwin, there will be no break, as I will be completing this within, up to 11 or 11:15. That's after that, I will also eat. I only drink in front of you. I have not eaten anything. So we'll take food together after completing this session. So don't worry. Okay. This is very important. This is very important for you. Now your food, your everything is this one. You can take food, after half an hour. Now, have a look. Phenol reacts with concentrated HNO3 in presence of concentrated H2SO4. That means whenever phenol is treated with concentrated HNO3, we know picric acid is the major product. So picric acid will be the product. Picric acid will be the product. After that, formylating agent in Gutermann-Koch reaction. Gutermann-Koch reaction means it is reaction of benzene with COHCl and in presence of AlCl3CuCl having, formyl group, resulting in the formation of benzaldehyde. That means in presence of COHCl. This is formylating what we call agent in this. After that, phenol can be converted into 1,3,5-tribromobenzene. This is very, very important question. Phenol is to be converted. Phenol is to be converted to 1,3,5. 1,3,5 tribromobenzene. You have to convert this into this. Now the question is, which among these is correct? Have a look. First of all, we will do bromination of phenol, but in polar solvent, or we will treat phenol with bromine water. What will happen? Phenol will result in the formation of, 2,4,6-tribromophenol. White precipitate of 2,4,6-tribromophenol will be obtained. After that, this is converted to this. We have to remove only oxygen, and this can be removed with the help of zinc dust. So now tell me, what will be the correct option? Correct option is bromine water and zinc dust. Bromine water and zinc dust. This is correct option. It's not zinc dust and bromine water. It's not bromine water in non-polar solvent. So it is bromine water and zinc dust. After that, we will be having another question. But before that, let me know in the chats if this is clear to you, everyone. Is this clear to you, everyone? Is this visible to you, everyone? Is this visible? Is this visible? If not, then I will be, writing this like. So, it is question is, in the reaction, reaction is like this. Reaction is like this. It is CH3 whole 3. Then it is CO. Then it is CH2. Then it is CH3. Then it is HI. And after that it is heat. Heat is there. But HI is only 1 mole of HI has been taken. Only 1 mole of HI has been used over here. Then question says the product or products formed is R. Now first option is, you can solve this question. This is very, very easy question. It is this one. And CH3 CH2I. Second option is CH3Ci, then CH3 tertiary butyl iodide, and it is CH3 CH2OH. Third option is tertiary butyl iodide once again. But remember, you have to take only 1 mole of HI, CH3 CH2I. Fourth option is CH3, then it is C, then it is O having a positive charge on oxygen, then CH2, then CH3, then I. Then it is CH3, then it is H over here, then it is CH3. Have a look. These are the options. This is very, very important question. This is CH3 whole 3, then it is C, then it is O, then it is CH2, CH3. Now have a look. Aliphatic unsymmetrical ether is this. HI, this is but having only 1 mole. Upon heating, what will happen? We know this group is known as tertiary alkyl group. So whenever oxygen is attached to tertiary alkyl on one side, then it is always an SN1 reaction. So this is an example of SN1 reaction. So simply give I minus to this tertiary alkyl group. So break this bond, give I to this, H to this. So CH3 whole 3 Ci and CH3 CH2OH will be the product. CH3 whole 3 Ci, that means, and CH3 CH2OH will be the product. But if HI is taken in excess, not 1 mole, then product will be like this. Then this alcohol is converted to alkyl iodide, but it is written only 1 mole, hence it will become this. Second option will become the right option. After this, we will be having another question. Have a look and tell me the answer. An alcohol gives turbidity with HCl in presence of zinc chloride, that means Lucas reagent. Only on heating, the alcohol is. So it gives Lucas, it gives turbidity, that means it reacts with Lucas reagent, but only on heating. This is tertiary alcohol. It reacts without heating. This is an alcohol which can form a very stable carbocation because of resonance, so it can also react, it can give turbidity immediately. This is primary alcohol. Primary alcohol never gives turbidity with Lucas reagent until and unless it is heated. This is phenol. Phenol never form carbocation. It never shows turbidity. Why it cannot show, turbidity? Because we know phenol is in case of phenol, CO bond is very strong, so it is difficult to break because this bond is strong due to partial double bond character. So remember, phenol never shows turbidity even upon heating. Now question is, which among these show turbidity? That means reacts with, Lucas reagent, but only on heating. So the answer is 1 degree alcohol. 1 degree alcohol is the right answer. After this, After this, we will be having another question. Following reaction is known as phenol chloroform NaOH followed by acidification resulting in the formation of salicylaldehyde. Very important reaction known as Remer-Timmer reaction. So it is simply Remer-Timmer reaction. So this is Remer-Timmer reaction. Simple. Phenol gives salicylaldehyde by treating with chloroform and in presence of base followed by acidification. Next. Which of the following reagent attach on the benzene ring in Remer-Timmer reaction? Remember, it is CCl2, but it is neutral CCl2, not negatively charged CCl2. Dichlorocarbene is neutral. Remember that. After that, we will be having another question, and a very good question. Now, let me know if this slide is visible. Let me know clearly. Is this slide is visible? Yes, this is visible. Now, tell me the answer. Tell me the answer. Tell me the answer. What will happen? What will happen over here? What will happen over here? First of all, it will result in the formation of, first of all, this CH3OH, it will result in the formation of like this. H positive, it will react with H positive first of all, and it will result in the formation of OH2 with a positive charge. Like this. Finally, it will lose this water molecule and it will result in the formation of a carbocation over here. Carbocation will be formed over here. After that, this hydride will be shifted. When this hydride will be shifted, let me show over here. 1,2 hydride shift will take place and it will result in the formation of a carbocation over here. More stable carbocation. Then hydrogen will be lost either from this or this. So H positive will be lost and it will result in the formation of a major product like this. This will be the major product. So, which among these is the major product? Major product is first one. Major product is first one. After that, arrange the following alkanols. That means those alcohols which have been derived from alkanes. So, arrange the following alkanols ABC in their reactivity order towards acid catalyzed dehydration. So, these are clear. Now, what will happen? You have to remove OH and form a carbocation. Remove OH and form carbocation. Trick wise, you can remove OH and form carbocation. This carbocation is more stable tertiary alcohol. This is the carbocation formed from tertiary alcohol, so more stable. After that secondary, after that primary. We know. Rate of dehydration. Rate of this dehydration of alcohol. Rate of dehydration of alcohol in say presence of acid, that means acid catalyzed dehydration of alcohol is directly proportional to stability of carbocation. So more stable the carbocation form, that means tertiary, then secondary, then primary. That means it is B, then C, then A. B, C and A will be the right answer, right option. Tell me in the chats quickly, is this clear? Tell me, let me know in the chats, is this clear? After that, we will be having another question. In a set of the given reaction, acetic acid yielded a product C. Okay, so C product would be, have a look. Let us, say simply solve this question. This is CH3COH. Whenever CH3COH is treated with PCl5, replace OH by Cl. That means we will get CH3C double bond O and Cl. Acid chloride will be formed. So this is A. This A upon treatment with benzene in presence of AlCl3, that means Friedel-Crafts acylation will be there. So it will result in the formation of acetophenone like this. This COCH3 will be attached to this and this is B. You know that. After that, this B is treated with C2H5 MgBr. That means this is having negative charge, this is having positive charge. Have a look. This negative part will attack this and it will result in the formation of an addition product like this. Addition product like this will be formed. See, O minus MgBr. Have a look. This will be formed. Then here it is C2H5. Here it is CH3. Finally, second step is you have to hydrolyze this. So hydrolysis of this. Hydrolysis simply results in the formation of alcohol like this. It is C to which C2H5 is attached. to same carbon CH3 is attached, to same carbon OH is attached. Have a look and tell me, is there any carbon to which COH, C is attached to OH, C is attached to C2H5, C is attached to CH3, C is attached to C6H5. So fourth option is the right option. Fourth option is the right option. After that, we will be having another question. But before that, let me know in the chats, is this clear? Let me know in the chats, is this clear? Come on. So toluene on treatment with chromyl chloride. Remember, this reaction is Itard's reaction and the product formation will be benzaldehyde. Simply, product formation will be benzaldehyde. After that, we will be having another reaction. This is acid chloride. Acid chloride on treatment with Rosenmund's catalyst. Reaction is known as Rosenmund's reduction. Acid chloride on treatment with Rosenmund's catalyst. Say for example H2 PDBaSO4 with small amounts of sulfur or quinoline results in the formation of what? This is very simple reaction. What we have to do during Rosenmund's reduction, we have to remove simply the Cl by H. That means our product will be like this. Product will be like this. So aldehyde will be obtained. Yes, RCHO will be the product of Rosenmund's reduction. After that, my dear students, the reagent most suitable for converting primary alcohol into an aldehyde. Primary alcohol to aldehyde. Reagent, oxidizing reagent must be mild oxidizing reagent. Have a look. K2Cr2O7H2SO4 is a strong oxidizing agent. KMnO4NaOH, strong reducing agent. Pyridinium chlorochromate means PCC. And its solvent is dichloromethane. This is what we call mild oxidizing agent. HNO3 is also a strong oxidizing agent. So it is this pyridinium chlorochromate which can convert primary alcohol to aldehyde. Others will convert primary alcohol to carboxylic acid. Next, Stephan reaction. What is Stephan reaction? Have a look. During Stephan's reaction, cyanide is treated with SnCl2 HCl. Then first of all, aldimine is formed. Or aldimine is formed. Then its hydrolysis results in the formation of aldehyde like this. Because we know when two OH groups are present to the same carbon, it will lose water molecule and will result in the formation of aldehyde. So we have to, choose the correct option. So it is reduction of what? Reduction of alkyl cyanide, that means this one, with SnCl2HCl and hydrolyzing the intermediate aldimine. Aldimine is undergoing hydrolysis. So option number 3 is the right answer. Exactly at the rate of Yadla Vamsi. Okay, sorry if I couldn't pronounce your name. Sorry. After that, we will be having another question. But before that, let me know in the chats if this slide is visible to each and everyone. If this slide is visible to each and everyone. Okay, now have a look. This question is directly from a very important reaction, and that reaction is known as aldol, cross aldol condensation. Have a look. Product is given. You have to find out X. That means you have to find out reactant. So how will we go from product towards reactant? Retroaldol. Have a look. Simply you just broke this carbon-carbon double bond. Give oxygen to that side which does not have any C double bond O group. So give oxygen, that means double bond O to this, and give 2 hydrogens to this. So one product will be acetophenone, one reactant will be acetophenone, another benzaldehyde. Benzaldehyde is given, that means X is acetophenone. Is there any acetophenone? Benzene COCH3, yes, this is acetophenone. So this is the product. Simple way. This is very simple. After this, we will be having another question. Acetone gives test with, what is acetone? What is meant by acetone? Acetone means this one, ketone. It is ketone. Ketone can show 2,4, this one, 2,4-dinitrophenyl hydrazine. Yes, it can show this test. It will show 2,4-DNP test. Fehling solution. Ketones do not show Fehling solution. Similarly, do not show Fehling's test. Similarly, it cannot react with Schiff's reagent because only aldehydes respond towards Schiff's reagent. That means acetone gives test with what? It gives test with only 2,4-DNP. That means first option is the right answer. After that, another reaction is this. This is very important reaction, Cannizzaro reaction. So have a look. Question from that. Question from Cannizzaro reaction. Have a look. Now, there are two CHO groups, and in presence of concentrated NaOH, what you have to do is you have to oxidize one CHO to COONA and another to and you have to reduce another CHO to alcohol, or you have to reduce one and oxidize one. This is simple oxidation reduction reaction. Now, answer will be option number 3, because one CHO has been reduced to CH2OH, another has been oxidized to COO minus. No, it's not. Option number 4 is not the right answer, because here both CHO groups has been oxidized. One has to be reduced, one has to be oxidized during Cannizzaro reaction. Another reaction. Another reaction. Very, very, very simple reaction. Another reaction. Have a look. This is, consider the following sequence of reactions. This is clear, I think so. This slide is clear. Now, let me know quickly. Now, this is CH3CO CH3. Can I write like this? It is CH3, then it is CO, then it is CH3. This upon treatment with NaOH and heat, that means this is simply aldol condensation. So, write down another like this. Write down another like this. Write down another like this, because we know upon treatment with base and heat, you have to lose water. Alpha hydrogen, 2 alpha hydrogens from one molecule and oxygen from another molecule, so it will result in the formation of this. So this is alpha beta unsaturated ketone, which is formed during condensation. So this is A. Now this on treatment with lithium aluminium hydride, what will happen? This C double bond O will reduce, but this C double bond C will remain unaffected. So it will result in the formation of CH3C, CH3 double bond CH, and this results in the formation of C single bond O, give hydrogen to this, give hydrogen to this. So it will result in the formation of this product. Is this any product? So CH3 whole 2 C, yes. Double bond CH, yes. CHOH CH3. Exactly, this is the right answer. This is the right answer. After that, we will be having another question. We will be having another question. Come on, my dear students. Come on. Come on, come on, come on, come on. Our class is up to maximum 40 minutes more. That's it. That is it. That is it. Come on. Maximum 40 minutes more. But let me know in the chats if this slide is visible. Yes, this slide is visible. Now, let me show you this reaction. Reaction is like, first it is benzene. Then it's on treatment with alkyl chloride followed by, say in presence of anhydrous AlCl3. That means this is Friedel-Crafts alkylation. First of all, you have to convert this into toluene. That means this is P. After that, this is treated with NBS. What will do NBS? NBS will do benzylic bromination. So allylic or benzylic bromination. Here it will do benzylic bromination. So it will replace this H by Br. So this is Q. After that, KCN. You have to treat it with KCN. So replace this Br by Cn. So we will get a structure like this, CH2Cn. After that, so this is R. After that, hydrolysis. But it is not saying whether this hydrolysis is complete or partial. When it is not saying partial or complete, you have to do complete hydrolysis of Cn. And complete hydrolysis of Cn results in the formation of carboxylic acid. So convert Cn into carboxylic acid. So this is S. So we have to find out S. Now tell me the right answer. What is S? C6H5CH2COH. Is there any option C6H5CH2COH? So this is the right option. This is the right option. After that, another question. The Hell-Volhard-Zelensky reaction. That means HVZ. What is HVZ? HVZ reaction is reaction of those carboxylic acids which contain at least one alpha hydrogen, and it's halogenation of such carboxylic acids by using halogen, whether it is chlorine or bromine, in presence of red phosphorus, followed by hydrolysis. So what will happen? One of the hydrogens is replaced by halogen. So it generally takes place at alpha position. Generally, halogenation takes place at alpha position in HVZ. So we have to find out the answer. So Hell-Volhard-Zelensky reaction is used for preparing beta haloacid, gamma halo acid, then acid halide, alpha halo acid. It is alpha halo acid. So fourth is the right option. After that, another question, very important question. But before that, this is simply an example of an example taken from NCERT. It's written there. So this is phthalic acid. This is phthalic acid. Have a look. This is phthalic acid. We know phthalic acid on treatment with ammonia, remember, results in the formation of ammonium salt of this phthalic acid. But upon heating, loses water molecule. This will lose water molecule, this will lose water molecule, and it will result in the formation of phthalimide. But this upon strong heating, once again upon heating, I mean to say, strong heating or heating, loses ammonia molecule. Here water molecule is lost, here ammonia molecule is lost, and it will result in the formation of phthalimide. This is simple example written in what we call your NCERT. So the question is saying, if now this is treated with ammonia and after heating, it results in the formation of phthalimide. After that, we will be having another question. But before that, let me know in the chats if this question is visible to each and everyone. Is this slide is visible to each and everyone? Yes, this is visible, I think so. Is this visible? Is this visible? No, it's not visible. It is not visible. Let me write down. This is CH3COOH on treatment with SOCl2. It gives A, which on treatment with benzene in presence of anhydrous AlCl3 gives B, which on treatment with HCN gives C, which upon hydrolysis gives D. So we have to find out then the structure. So the structure of D would be, first option is like this: CH3 OH, then COOH. Second option is CH3, then OH, and then COOH. Third option is like this: CH2, then it is C, then it is CH3, then it is OH, then it is COOH, and then fourth option is like this. Here fourth option is like this. You have to tell me the answer. This is CH2 whole 2, then it is C, then it is CH3, here it is COOH, and here it is OH. You have to tell me the answer in a set of, question is in a set of reactions, acetic acid yielded a product. Acetic acid yielded a product D, and we have to find out what is D. Come on, let's solve this question. CH3COOH, can I write it in this fashion? On treatment with SOCl2, we know we have to replace OH by Cl, so CH3COCl will be our A. This on treatment with benzene in presence of AlCl3 anhydrous. This is simply Friedel-Crafts acylation reaction, so it is COCH3. So this is B. This B on treatment with HCN results in the formation of cyanohydrin. We know it will result in the formation of CN will attack on this carbon and oxygen will acquire this H. So cyanohydrin will be formed like this. After this, so this is C. C on treatment with water, that means this is hydrolysis. So upon hydrolysis, you have to convert cyanide into COH. That's it. That is it. So this is the question. So this is D. So our D is we have to say what is D. D is that carbon to which OH, CH3, COH and benzene is attached. OH, CH3, COH and benzene or phenyl ring is attached. So C is this one. C is phenyl ring attached to carbon, and to that carbon OH, COH and CH3 should be attached. So this is what we call C. After that, another question is, another question. Come on. Another question. Another question is, have a look. Is this clear? Let me know quickly. Is this question clear to you? Is this slide visible to you? I mean to say. You have to tell me what will be the answer. What will be the answer among these four options? Very, very simple, but these are the questions which can be asked in your NEET examination. Now, so this is treated with R and it will result in the formation of aspirin. Have a look. What is aspirin? Have a look. What is aspirin actually? So aspirin is actually like this. O, then it is COCH3. That means it is acetyl salicylic acid. This is salicylic acid. Orthohydroxybenzoic acid. And what is aspirin? Aspirin means acetyl salicylic acid, or it is acetoxybenzoic acid. So this is acetyl salicylic acid. That means we have to do acetylation. That means we have to replace H by COCH3. But acetylating agent is that in which CH3CO group is present. That means it is this one. So with the help of acetyl chloride, you can do acetylation or acetic anhydride, but acetic anhydride is not an option. So acetyl chloride is the right option. After that, another is like this. Another question is like this. Have a look. Have a look and tell me the answer. So this is benzoyl chloride. This is benzoyl chloride. Have a look, my dear lovely students, have a look. Benzoyl chloride plus carbolic acid. Let me know in the chats what is meant by carbolic acid. A very good question. What is meant by carbolic acid? Let me know in the chats quickly. What is meant by the carbolic acid? What is carbolic acid? I am waiting for your response. Come on, quickly. What is carbolic acid? Exactly. Carbolic acid means phenol. Carbolic acid, another name of carbolic acid is phenol. Exactly. Now tell me, when you treat benzoyl chloride when benzoyl chloride is treated with phenol, what will happen? What will be the product? What will happen? And what is the name of that reaction which takes place there? Come on, tell me what is the name among these? Is that Friedel-Crafts reaction? Is that Schotten-Baumann reaction? Is that benzylation? Is that both benzylation as well as Schotten-Baumann reaction? Have a look. This is what we call phenol. This is phenol. This is what we call benzoyl chloride, like this. This is benzoyl chloride. If we treat them together, so we can say benzylation, because benzoyl group has been introduced in phenol. So this is benzoyl group. Benzylation of phenol has been taken place. Remember, any compound which donates H as H positive, that means any acidic hydrogen containing compound, whether it is phenol, whether it is aniline, so any acidic hydrogen containing compound, when undergoes benzylation by using benzoyl chloride, that reaction is known as Schotten-Baumann reaction, which means it is benzylation of phenol as well as Schotten-Baumann reaction. So option number 4 is the right answer. That means Schotten-Baumann as well as benzylation. After that, we will be having another reaction, that is CH3, C double bond O and OH. On treatment with ammonia gives obviously ammonium salt, which upon heating loses water and results in the formation of amide. Amide on treatment with PCl5. When treated with amide, it acts as a dehydrating agent and it results in the formation of cyanide. So what will be the option? Option number 1, it is obviously cyanide. So this is first option. This is third option. Have a look and tell me the product. I have already told you that what will happen over here. Now let me know in the chats which option is the correct one. Let me know in the chats which option is the correct option. Now have a look what will happen actually. First of all, you are having CH3COOH. Then this on treatment with ammonia gives CH3COONH4. That means normal acid-base reaction takes place. Then after that, upon heating, it will lose water molecule. Ammonium salt will lose water molecule upon heating and results in the formation of amide. Amide on treatment with PCl5. PCl5 acts here as a dehydrating agent and water will be lost over here. When water is lost, it results in the formation of CH3C triple bond N. So cyanide will be formed. That means option number 1 is the right answer. After that, next question. But before doing this, let me know quickly in the chats, is this slide visible? Is this slide visible to you? Okay, this is visible. I think this is visible. Now have a look. Whenever carboxylic acid is treated with alcohol, have a look. Whenever carboxylic acid is treated with alcohol, say for example CH2CH3, I mean say ethanol is this, in presence of acid, so we know water will be lost, but water will be lost in such a way that oxygen came from carboxylic acid, and that clearly indicates ester will be CH3CO, and then in this ester it is O of this alcohol which is formed. That means O18 will come to ester, and in water there will be normal oxygen which is having mass number or atomic mass what we call 16. So this is having isotope 18. So it is option number 1 which is the right answer. So in case of esterification, oxygen in water came from carboxylic acid and oxygen attached to CH3C double bond O is from what we call alcohol. I hope this is clear. After that, we will be having another question. Question is CH3CN on treatment with NaC2H5OH. This is CH3CN. Cyanide on treatment with sodium in alcohol gives X, which on treatment with HNO2 nitrous acid gives Y, which on treatment with KMNO4 OH minus followed by acidification gives Z. Now have a look. Have a look. What will happen over here? It is basically CH3C triple bond N, which on treatment with sodium in alcohol, that means it is actually a reducing agent which will reduce this cyanide to primary amine like this. Hydrogens has been added across carbon triple bond nitrogen, so it gets primary amine. Primary amine on treatment with aliphatic primary amine on treatment with nitrous acid gives alcohol. Gives alcohol. This alcohol, that means, say this is X, this is Y. This alcohol on treatment with strong oxidizing agents like this, followed by acidification, then this alcohol, primary alcohol, is converted to carboxylic acid, so we will get CH3COOH. Acetic acid will be obtained. Acetic acid will be obtained. That means option number 3 is the right answer. Option number 3 is the right answer. After that, another question is, formic acid and formaldehyde can be distinguished by, this is formic acid and this is formaldehyde. They can be distinguished by, let me tell you, Tollens reagent, Benedict solution, Fehling solution can react with both these, but NaHCO3, sodium bicarbonate test, is shown by formic acid, but it is not shown by aldehyde, because sodium carbonate or sodium bicarbonate test is shown only by those acids which are stronger acids than carbonic acids, except paranitrophenol, which is weaker acid than carbonic acid, but still it can show sodium carbonate or sodium bicarbonate test. So with the help of sodium bicarbonate, we can distinguish what we call formic acid, that means carboxylic acid, and a formaldehyde. After that, another question. Another question is, in the given reaction sequence CH3CH2OH, KMnO4OH minus heat and H positive gives A. Have a look. We know this is strong oxidizing agent, so this will result in the formation of CH3COOH. First of all, CH3COOH, that means acetic acid. This acetic acid upon treatment with SOCl2, OH will be replaced by Cl, then NH3, so that Cl will be replaced by, or let me show you once again like this. First of all, CH3COH will be formed, so this is A. This on treatment with SOCl2 first results in the formation of CH3COCl. After that, on treatment with NH3, it will result in the formation of CH3C double bond O, and instead of that, it is amide which is formed. This amide, so this is B. This amide upon treatment with Br2KOH, say Hoffman bromamide degradation reaction, this C double bond O will be lost, so CH3NH2 and a methyl amine or aminomethane will be formed. Methyl amine will be formed. After that, another reaction, phthalimide. Phthalimide on treatment with KOH. Phthalimide on treatment with KOH. What will happen? It will abstract this hydrogen and it will result in the formation of this one. It is C double bond O, then it is N, then it is C double bond O, then N having negative charge and K positive will be there. Then finally, it is simply SN2 reaction. So normal SN2 reaction will take place. So it will result in the formation of N-ethyl. N-ethyl, that means CH2CH3. N-ethyl phthalimide, which is obtained. After that, finally hydrolysis will take place, so this bond will be broken, H goes to this, OH goes to this. Similarly, this bond will be broken, H goes to this, OH goes to this. That means once again phthalic acid and ethyl amine will be obtained. Phthalic acid and ethyl amine will be obtained. That means option number 2. Phthalic acid and ethyl amine will be obtained. Option 2. This is known as Gabriel phthalimide reaction. I hope you remember this. After that, we will be having another reaction. After this, we will be having another reaction. Come on, my dear students. We will be having another reaction. Another 10 to 15 or 20 minutes maximum. That's it. The end product B is formed in the reaction. End product B formed in the reaction. Have a look. First of all, reaction is like this. This is ethene. Ethene on treatment with Br2. First is Br2CCl4. That means we have to add bromine. So bromine will be added, vicinal dibromide will be obtained, but it will be anti-product basically. One will be above the plane, another will be below the plane. Okay. Now after that, KCN. This is treated with KCN, but in excess. That means you have to replace this Br by Cn. So product will be CH2. Can I write it will be one C triple bond N, another C triple bond N as it is in excess. Okay. After that, so this is what we call product A. This product is upon treatment with lithium aluminium hydride followed by hydrolysis. That means reduction. Convert this into CH2 NH2, convert this into CH2 NH2. So can I say it is CH2, single bond CH2, then this is converted to CH2 NH2, primary amine. This is also converted to CH2 NH2. That means 2 NH2 and 4 CH2 groups are there. 2 NH2 and 4 CH2 groups are there. So it is this one. Very, very, very simple. Very simple. After that, another reaction. Which of the following would undergo Hoffman bromamide reaction to form primary amine? Another question is that which of the following would undergo Hoffman bromamide reaction to form primary amine? Remember, it is primary amide. It is C double bond O NH2, whether it is R or AR, whether it is aliphatic primary amide or aromatic primary amide. This is the actual what we call substrate which undergoes Hoffman bromamide degradation reaction. After that, another CH3 CH2 CO NH2 on treatment with NaOH Br2. This is once again Hoffman bromamide reaction. So what will be the product? CH3 CH2, C double bond O is removed, then NH2. So can I say an amine is obtained? But if this amine in aqueous solution, it will act as a base. If it is base turns red litmus to blue. Base turns red litmus to blue. That means this one. Acid turns blue to red, but base turns red to blue. So this turns red to blue. After that, in carbylamine reaction, the reaction intermediate is dichlorocarbene. Reaction intermediate is dichlorocarbene. Simple question, but you must know what is carbylamine reaction. After that, you can say this. Otherwise, you don't know what is the intermediate of this. I mean to say carbylamine reaction. Otherwise, you don't know. Okay, amine whose product is insoluble in NaOH in Hinsberg's test. Remember, in Hinsberg's test, with the help of Hinsberg's test, we can distinguish primary amine, secondary amine, and tertiary amine. But when Hinsberg's reagent is treated with benzene sulfonyl chloride is treated with primary amine, it results in the formation of N-alkyl benzene sulfonamide, a solid, but that solid can be soluble in KOH. Question is, it's insoluble in KOH. That means it is that solid which has been formed from secondary amine. So this is primary amine, this is primary amine, this is secondary amine, this is tertiary amine. Our answer is secondary amine. After that, this is NHCOCH3 upon treatment with HNO3 H2SO4. That means this compound upon nitration gives. Have a look. This will donate its electron towards ring and increases electron density of the ring either at ortho or at para. But it cannot activate ring very much because COCH3 group is there. That means electron withdrawing group is there. But it activates ring, and it activates ring either at ortho or at para position. Hence, these two results in the formation of nitronium ion as an electrophile. So electrophile goes to either ortho or to para position, but major product will be para 1. So I will put NO2 at para position. So this is X. This is what we call our X. So this is X. After that, this X upon hydrolysis gives Z. What is Z? Upon hydrolysis, we know upon hydrolysis, what will happen over here? You have to break this bond, give H to this, OH to this. That means it is this one, para-nitroaniline is the major product. Para-nitroaniline is the major product. Let me know. Acha, okay. This is actually HNO3 and H2SO4. Then nitration. And this is NHCOCH3. This is phenyl ring. This is what we call H2O, H positive, and heat. Here Z is, you have to say what is Z. You have to say what is Z. First option was like this. It is meta-nitroaniline. Meta-nitroaniline. Second option is para-nitroaniline. Third option is like this. Have a look. This is third and then this is fourth. So our second option is the right option. Now, is this clear? Is this clear? Okay, this is clear. After that, we have another question. In this question is like this, I mean to say, in the reaction, the structure of the product. Come on. Tell me the structure of the product. X is. And this is the reaction. This is CH3 group, which is present at para position, and this is C double bond O NH2. This upon treatment with number 1 NaOH Br2 NaOH Br2 followed by a reaction with this one C double bond O and Cl. This is X. So you have to tell me what is X. What is X? Option 1 is this. Let me draw these structures for you so that it is more visible to you, because many of you will be doctors in the year 2026, and for my doctors I can do this much. I can do this much for my doctors. Now, tell me, my dear doctors, tell me what is the product? What is X basically? What is X? Try to solve the question. Try to solve that reaction and tell me what is X. Try to solve that reaction and tell me what is X actually. Come on. You can tell me. You can tell me easily what X is. Is this first option, second option, third option? Tell me which option is actually X. I am basically checking for you whether it is clear or not. Now it is clear. Have a look. Let's try to, solve the question. So it is like this. C double bond O NH2. On treatment with NaOH Br2 means Hofmann bromamide degradation. So remove simply C double bond O. Remove C double bond O from amide, and it will result in the formation of this primary amine. After this, you have to treat this with benzene or benzoyl chloride. What you have to do is, have a look. You have to simply replace this H by this group. I mean to say, you will get this one. This is NH and to this NH, C double bond O and this phenyl ring should be attached. Is any option like this? CH3 NHCOC60. Yes, this one. This is the right answer. Third one, CH3, then phenyl ring, NH, then CO, and then pH. This is the option. After that, aniline, question number 91, because we have to complete only 100 questions. This is question number 91. Come on, come on. Aniline on treatment with bromine water yields white precipitate of. It is 2,4,6 tribromoaniline. Aniline on treatment with, this is aniline. This upon treatment with what? Bromine water. That means bromination of aniline will take place at both ortho positions and para position. So white precipitate of 2,4,6 tribromoaniline will be obtained. After that, question number 92 or 91. Question number 91. Now, you have to identify Z in the given reaction. You have to identify Z. Let me write down what is this. This is HNO2. HNO2 at a temperature of 280 Kelvin. First. Number second is H2O, and then boil and gives X. These are the reagents. This X upon treatment with NaOH gives Y. This Y upon treatment with CH3I gives Z. Now, then among options, you have to find out which option is the right answer. So first option is like this. Here it is like this. It is like this. Now it is like this. Now I hope this is visible now clearly. This first option is visible now clearly. This is second option. This is visible also. This is visible to you also now. Have a look, have a look, have a look. Then after that, we will be having third option like this. OCH3. Then fourth option like this. I hope this is clear to each and every one now. This is visible to each and every one now. Have a look. What is the question? Question is aniline on treatment with nitrous acid, HNO2, at a temperature of 280 Kelvin. That means ice cold condition. Remember, it results in the formation of diazonium salt. Say for example, diazonium ion. After that, upon treatment with water but at high temperature, diazonium salt or diazonium ion is unstable, so it will result in the formation of phenol. After that, this phenol on treatment with NaOH results in the formation of sodium salt of phenol. That means sodium phenoxide. Why? Because this OH minus will abstract this H and it will result in the formation of O minus Na positive. This on treatment with CH3I, very, very simple. This will attack this and CH3 will be lost. Yes or no? If CH3 will be lost, so it will be simply reaction of phenoxide with alkyl halide. That means it is normal Williamson synthesis reaction. So we will get ether. We will get ether. So this is the right option. After that, another question is, another question is, come on my dear students, come on. Another question is, ArN2Cl minus upon treatment with CuCl, that means in presence of copper HCl, ArCl, chlorobenzene is formed. This reaction is known as Guttermann reaction because it is copper powder in presence of HX. This is Guttermann reaction. After that, in the following reaction, the product A is obviously this is coupling of aniline. So product A is para-amino azobenzene. That means option number 4, and this is a yellow dye. yellow dye is obtained. This is coupling reaction of aniline, and coupling takes place, coupling of benzene diazonium chloride with aniline takes place at para position of aniline. After that, we will be having a statement based question. Primary aliphatic amines react with HNO2 to give unstable diazonium salts. Primary aliphatic amine react with HNO2 to give unstable diazonium salt. Exactly correct. Exactly correct. This is correct. Statement 2. Primary aromatic amines react with HNO2 to form diazonium salt. That is correct. But which are stable even above? No. This is wrong. Because above 300 Kelvin, they are not stable. That means statement 1 is correct. Statement 2 is incorrect. Statement 1 is correct, but statement 2 is incorrect. That means it is option number, I mean say 4. Option number 4. Option number 4. So option number 3 is statement 1. Statement 1 is correct. Statement 2 is incorrect. Option number 4. Statement 1 is correct and sorry. Both statements. Okay. Option number 1 is statement 1 is incorrect. Statement 2 is incorrect. No. Option 4. Statement 1 is correct. Statement 4 is incorrect. After that, we will be having another question. Question is, which of the following is non-reducing sugar? Remember this forever. All monosaccharides, remember, all monosaccharides are reducing sugars. They are reducing sugars. All monosaccharides are reducing sugars. All polysaccharides are non-reducing sugars. And among disaccharides, it is sucrose and trehalose, which are non-reducing. Remember these points. So, question is, which of the following is non-reducing? So, it is sucrose. Maltose, lactose, they are what we call reducing sugars, and mannose is a monosaccharide, so it's always a reducing sugar. So, only saccharose and trehalose, they are the two, disaccharides, which are basically non-reducing. After that, maltose is made up of what? Two glucose units. One is alpha D glucose, another is also alpha D glucose. But one is alpha D glucose whose carbon number 1, and another molecule is alpha D glucose but whose carbon number 4 takes part in glycosidic linkage. So it is alpha D glucose and alpha D glucose. Alpha D glucose, alpha D glucose, alpha. So it is alpha D glucose, maltose. After that, RNA and DNA are made up of, very simple question. RNA and DNA are made up of sugar, phosphate, and what we call these bases. So sugar, phosphate, and bases, purine and pyrimidine bases. So they are simply sugar, uske baad sugar, then phosphate, and then what we call bases. Sugar, phosphate, and bases. After that, compare relative stability of the following resonance structures. These are the resonating structures. Now we know this B is neutral. First of all, write down neutral. That means B is the right option. That means either this or this will be the correct answer. After that, you have to find out number of pi bonds. Number of pi bonds here is 2. Here it is only 1. That means it is B, A, and C. B, A, and C is the right answer. Then we will be having another question. Sucrose on hydrolysis gives alpha what we call glucose and beta what we call fructose. It is alpha D glucose and beta D fructose. Alpha D glucose and beta D fructose. Alpha D glucose and beta D fructose. It is this one. After that, this is the last question, but let me know in the chats if this slide is visible to each and everyone. If this slide is visible to each and everyone. Is this slide visible to each and everyone? Is this slide visible? Let me know quickly. This is the last question of today's session. Now, remember my dear students, remember, here glucose never show, say reaction with one Schiff's reagent. This is written in your NCERT textbook. You can go through textbook. This is written there. It cannot react with Schiff's reagent, as well as it cannot react with NaHSO3. That means it cannot form that addition product of bisulfite. So with these two, it cannot react, because in general this glucose is basically not present in free aldehydic form. It's present in cyclic form, so it cannot react with these two. But it can react with Tollens reagent. It can react with this NH2OH, because in basic or acidic medium, this glucose cyclic compound, cyclic ring can be opened. That means it can react with others. So the question is with which it cannot react. It's one is Schiff's base and another is what we call NaHSO3. That means first option is B and another is E. B and E. B and E is the right option. So this is all from my side. So I am very thankful to all of you. So thank you and God bless you all. But I want thank you. I want green hearts and fire emojis from each and everyone if you like today's session. If you like today's session, I want green hearts and fire emojis from each and every one. And once I end the stream, I will be waiting for each and every one to do comment. But after end of this session, you have to comment. You have to, tell me that how was the session. Do you really like the session or not? You have to write down that in comments, not here, in comments after end of this session. After end of this session, you have to be there to comment me, because I will be waiting for your comments, and everyone will comment that from which place you have watched this session, from which place you were watching this session. I will be waiting, because I will check each and everyone's comment that from which place you were watching this. So this is all for today. Thank you and God bless you. Take care and love you all.